Okay. Good morning, everyone. Admit me to ride on the existing protocols. This morning, I will be discussing briefly on the work we've been doing on drought modeling in South Africa. So yesterday, we've been talking about groundwater and all the rest of the rain, but this morning, we'll be talking about lack of water. So, yeah, as we all know, drought is a prolonged period of lack of water or precipitation. And there are various types of drought. We have the hydrological drought, meteorological drought, socioeconomic drought, and what have you. But within the context of our research work, we are focusing on meteorological drought, which is a very short time span, maybe between 3 to 6 months of drought situation. So that is where the domain of our work. And we all know drought can occur everywhere on the surface of the earth. And it is not a regional something, it is a localized action. For instance, drought can be maybe in where we are presently, can be having a lot of rain, but in another place, maybe in Durban, they can be lacking rain. So it's a local action, and it has been described as a complex situation. It is not just a straightforward situation that you plug and play and say, oh, this is just the cause of drought. A lot of things interplay to result in drought. And its effects are enormous: economic, social, health-wise. It affects the agriculture, environment, and what have you, and a good number of them. Now, in the case of South Africa, research has shown that drought in South Africa is caused by a number of things. Increased water demand as a result of urbanization. We talked about increase in population, waste management. We also look at reduced investment in water resource management, and then agriculture, because we realize that 60% of the water demand in South Africa is as a result of use in agriculture. So that's what literature have also shown. And then, I mean, this situation is not expected to go away in a very short time, because if all these indices that give rise to drought are not taken care of, there is no way you should expect them to, the situation to be abated. Now, we also realize that most of the responses that are recorded in terms of drought mitigation are channeled towards agriculture. How do we reduce the effect of drought in order to take care of agricultural production? So that's what research has also shown. So in view of this, now we say, okay, let us look at drought. How do we model drought? Already some works has been done already. I'm not disproving that, but we now look at how do we model drought in most of the locations. So in that case, we try to look at the drought indices that are available. But the one that has been recommended by World Meteorological Organization is the Standard Precipitation Index, which is very simple to use. You use one single parameter to, look at the drought segregation. And then in SPI, it is categorized into 4. You have the mild drought, moderate drought, severe drought, and the extreme drought. And the indices are given in the table there, table 1 there. So that's the reason why we chose to use a standard precipitation index. It's univariant. Then we also further looked at, previously in other locations, drought has been modeled. What are their results using different types of machine learning? Now, this particular table shows us that no one method of drought monitoring is perfect. For instance, AMFIS may perform very well in Iran, and when you bring it down to South Africa, it will perform woefully. Or you look at ANN may perform very well, maybe in Australia, you bring it down to South Africa, it doesn't perform. So no one method of drought prediction works perfectly in all locations. So that's why we have to also try our own, create our own model for our own specific environment. Now, to do this, we look at 4 different locations. Umtata, Orpington, Springbok, and Cape Town within the Cape region. So Western Cape, Eastern Cape, and Northern Cape. So we look at these 4 locations as our pilot locations for drought modeling. Now, the uniqueness of what we are doing in this regards is we are looking at various meteorological parameters. We look at them and see which one of them can give us a better result in each of these locations. So in our input, we made use of aerosol optical depth, relative humidity, temperature, evaporation, evapotranspiration data, soil wetness, and sea surface temperature. So to see how we can model drought, and our target there is SPI. Now in this SPI, we looked at SPI 3 and SPI 2, which are 3 months interval and 6 months interval drought monitoring. And then our data sources vary from GPM, which is a Global Precipitation Mission data, satellite data, MERA2, Automated Surface Observing System, Earth, and Moody's data. So it's a different variety of data that, different sources of data that we combine together in this model. Now, straight to the result. This is the SPI graph for the 4 locations considered. Now, the left-hand side is for SPI 3 and the right-hand side is for SPI 6. Now, if you look at these points, any line below 0 indicates drought situation. So it may be mild drought, severe drought, or moderate drought. So any line below 0 means that drought occurred within that period. So we further went down to now categorize all of them. We found out that 80% of the time, over 80% of more than 80% of the time at Cape Town, they experience drought. And then these droughts, if you look at the tables, okay, for instance, let's take the tables one after the other. This is for mild drought, so though I have to recalculate this one. But for moderate drought, we find out within the period of study, 17% of the time, Cape Town experienced moderate drought and all down there. And also, we integrated the wetness because it's not just about drought. Also, in the SPI calculator, you can calculate the wetness and all the rest of them. We found out that also at different points in time, these locations also had maybe very wet times or moderate wet times or extreme wet periods and all the rest of them. So we integrated all of them here. And we found out that most of the time, generally, most of the time, these locations experience one kind of drought, more drought than wetness within this study period we considered. Our study period spanned from 2002 to 2021, so roughly around 20 years. So we found out that the drought situation, most of these locations experience one kind of drought, more drought than rainfall. Now we model this. We try to integrate all these data. Now, when you have anywhere you see all, it means all the data we accumulated, we are all put together in the model to see how it will model, how the output will come out, how it will look like when we try to model SPI. So all implies that we integrated AOD, relative humidity, temperature, evaporation, evapotranspiration, soil wetness, and sea surface temperature. Put them together as the input data to see how it will model SPI. And then wherever we have RHTP, means relative humidity and temperature. So these are when we plotted the model data and the measured data. The red line indicates model data, the blue line indicates the measured data. So these are how each of them perform. So you can see at this point, the model performed relatively better But at this point, when we use relative humidity and temperature, the model didn't perform well. Now, we did the same for all the locations. In all, we generated approximately 88 models. So 22 models for each location, 4 locations times 4, 88 models. And then the tricky thing I didn't put here is that when you are using artificial neural network, especially in MATLAB, you find out one of the most difficult things to do is to select your number of hidden layer neurons. Now, for us to do that, we have to develop a code that will help us select the accurate number of hidden layer neurons that we impute, which is the most tricky thing in artificial neural network. And then for us to do that for each of these models, for us to do that, we have to run about 100 algorithms. So to select the accurate number of hidden layer neurons for each of these locations, we have to run about 8,800 other models to get the hidden layer neuron, the best hidden layer neuron, before we start modeling. So now we tabulated our R squared, which is which we use as the indicator for to see the model performance at the different locations. Now we realize that here, when we integrate all the parameters, the model performed very well, especially when we consider both time scales. Now, when we start substituting the parameters, we realize that the model starts performing abysmally, especially when we are considering long-term drought at the SPI6. Now, later, we realize that one parameter that we would have integrated in this model is the surface albedo, which will give us the fraction of solar radiation reflected back into space. And which invariably, we know that if the surface albedo is very high, it means drought will not occur. But if the surface albedo is very low, it means that the tendency for drought to occur will be there. So in the next model we are going to generate, we will integrate surface albedo to see how the model will definitely behave. Now, when we try to integrate all the R squares together to see how the parameters differed in all the locations, we found out that at Umtata here, you find out this is the red line is for SPI6 and the blue line is for SPI3. We found out that the model varied very much here, and also at Springbok, but at Cape Town and Uppington, the different model combinations performed relatively good. I mean, the variation was not much, but we found out that for SPI3, the model was predicting relatively better in most of the locations. But when we start looking at long-term drought, the model started performing abysmally. Now, we also said, okay, how do we quantify? How do we look at these different locations? How does the mean values of the different models behave? So we did a comparison using ANOVA, and we come up with this. Anywhere the p-value is less than 0.5, it means that the mean values of the two models, both the measured and the modeled, differed. Now, we cannot find which of the model varied from the measured data. So in that case, we look at the next image. Now, this implies, at this point, this is our measured. The first one here, the comparison here, this is our measured, this measured, this is measured. Now, anywhere you see the red bars implies the model and the measured, their mean values varied. So you find out those locations where we have our p-value that are very low at this point, we'll be able to identify the mean values, which are these ones here, that varied significantly from the measured. So the implication of this is that in all these locations, not every combined parameter can predict drought effectively. So there are certain parameters that you put together and it will give you a good output. It will give you a good prediction for the drought situation there. Now, trying to summarize, we found out that 60% of the time under consideration, Umtata, Springbok, and Orpington experience one kind of drought or the other, while Cape Town experiences 57% of the time. I want to say at this point, from the result we have, we know about the day zero in Cape Town and all the rest of them. I think Cape Town is not the worst hit when it comes to drought in South Africa from this result. Maybe media propaganda, or because they are more outspoken, they tend to present their problem more. That is from my own point of view, from the result I have here. And also, we realize that in this model, in modeling drought, evaporation data and evapotranspiration data are very, very important. And generally, also, when we have a combination of relative humidity, temperature, and soil wetness, and when we also add evaporation data to it, we find out that the models perform better when we have this a combination of these parameters in almost all locations gave us a relatively better result. So in that view, we want to recommend that modeling drought, the better inputs are for these locations are relative humidity, temperature, soil wetness, and evaporation. They should be included in the model result. And then the work is not yet over. What do we do next? We are thinking of expanding the project beyond this, maybe gridding South Africa, putting South Africa in a 1-degree grid map and picking out one location each. And then at the end of the day, we look at a more comprehensive drought map, like what I have here. This is a 1-degree gridded map of South Africa. So we can pick up a location here, pick up a location here, pick up a location at different center of the grids, and then calculate the SPI for each of these locations, and then run a model to create a more generalized map of the drought situation in South Africa, irrespective of the location. And then further look at drought, predict the drought for the next 5 years. Personally, I won't recommend predicting drought for more than 10 years because it's something that you cannot beat your chest and say it must happen, and it will happen. So it's a more complex situation. So taking it maybe at 5 years, 10 years interval will be my own personal recommendation. All right, thank you for your attention.
Thank you. You made it, I think, in 20 minutes time. Let's have questions, engagement for 5 minutes. Comments, questions, observations. Let's go.
Just one. I'm not an expert in this.
Okay.
I was taken aback by the R square.
Okay.
Actually, you mentioned that R square. It looks like a fraction to me. It's less than 1.
Yeah.
Is it some kind of a ratio?
It's not a ratio.
What is it?
R square varies from -1 to 1. And the closer the R square to 1, the better the result. So it's just like R square of 0.9 means 90% chance that the model is correct. R square of 0.1 means just 10%. R square of 1 is 100% that the model was able to predict effectively the measured results.
So it looks at the performance of the model.
Yeah, it's just a performance indicator.
Although I was just looking at you telling me, the either the parameters or, whether the critical issue of these two heads development that actually brings that side of the money. But that's fine.
Okay.
Food for thought. More comments on the same R squared. Just with observation, I had a question, but it's observation now.
Okay.
Why was R squared used and not adjusted R squared?
Well, I have results for both. I can present results for adjusted R squared. So I have output for both R squared and adjusted R squared.
No, that's fine.
Yes.
Next is the assumption. I was not very clear about assumption. If I look at that map,
Okay.
Huffington and Cape Town, without doing any scientific study, knowing the geography of this country, the condition of this country, being the Sahara Desert or the desert of this country, what would be the prior assumptions? Which would be hotter than the other? Which would be drier than the other? Without it going to the lab. Were the assumptions considered?
Well, I know that Uppington will be, because Uppington is closer to the Kalahari Desert. So definitely Uppington will be drier than Cape Town on a face value. On a face value. But then, when you are talking about climate and all the rest of them, you cannot just beat your chest and say it is 100% that it must be this. There must be some assumption that, okay, this is what should happen, but then other things may come into play, like the wind pattern and all the rest of them may change, and then the situation may vary.
More comments? Yes.
Yeah, thanks for the talk. Just my comment or question as to what the professor just mentioned. Given the nature of the variation of climate across the country, in line with what you anticipated going the study, I think it should be a good thing to expand to the eastern parts as well as the northern parts of the country, because the climate and the rainfall pattern will be balanced in the country, so that we can test the robustness of the modern weather, that is really what you expect. That's just the main comment. And the question, what could be the main driver of the differences, particularly if you compare Springbok and Uppington? Because I think the weather patterns or the climate variation in that area is somehow similar.
Well, Springbok is closer to the Atlantic Ocean. And in a previous work we did, not this one, we found out that the wind patterns in all these locations are not exactly the same. And what drives most of the time rainfall, for instance, if close to the Atlantic Ocean there's evaporation, and then, there's movement of moisture from the ocean down here. You find out, though we are looking at it as one map, but the distance are not just very close. So it may be Springbok may have more rainfall than Uppington because of the proximity, maybe to the ocean, evaporation, and all the rest of them, and the prevailing wind pattern. Okay, that's what I think there. Yeah, but I can still further look into it. Yeah, sure.
Was the data validated through other means aside the statistical
The
results, was it validated?
Yeah, sure. Okay, what happened is that all the data we have for the 20 years, we used about around 16 years to run our model, and then 4 years for validation. So the results you see here, sorry. Oh. Yeah, these graphs means for this period, when we run our model, we use from 2000 to 2017 to run our model. The remaining 2018 to 2021 data we are separated, and we use it for validation of our model, which is what we plotted down there. So that's what we are using in comparing the behavior of the model, whether the model performed well or whether the model did not perform well. I don't know if I answered your question correctly.
It depends, you know, there are different modes of validation.
Okay.
You know, there could be something called the grand routing, you know, whereby after you finish your model, you actually have what is available on ground. You know, this is the model based on simulation. You know, then there are other ways in which you can validate your model as well.
Sure.
It could be as a result of using your statistical or even using the same model, you know, in a different catchment or a different environment and comparing them again to see how the model works. So it depends on how you want to look at the validation.
You know, this what we are using here is a historical data. So we cannot rewind the hands of time to go back to the place. And something that is very important here is if the model I use for maybe Umtata, I try to validate it with the one, maybe the data from Springbok, we realize that it doesn't work in this case in drought because of the local actions, localized behavior of drought in each of the locations, and which are also well documented in literatures.
Sorry, before you continue, that brings me to two things here.
Okay.
That I would rather suggest that you have a situation whereby you apply. I understand at the beginning of your talk to say, oh, what works in Iran may not work in South Africa. But you need different set of model, you know, apply it in the same catchment that you have done, you know, and compare to see how you perform better. It's a way to validate. That is one. Second one is the grand routine, which you can, you know, use some parameters there, maybe the vegetation, you know, or something, to also see how they behave in those particular period. That is two. Three is that you can also validate it with if you say you don't want to compare what is here with what is on Tata, because if you are developing a model, let's say that area, how does that model itself works in another area? You understand? So, and lastly, is that you use another set of parameters entirely different from the ones you have used for that same area and compare as well. So it gives you have a bigger picture.
You know.
So just to jump in also.
Okay.
I mean, given that we are predicting droughts.
Yeah.
We know that certain years in the past when drought occurred, just to compare a prediction to what is new. So that way validating the model.
Okay, maybe what we can do in that situation is specifically extract data for those times and then predict those periods and compare with what we have. Okay. No problem. It's not an issue. We can always do that.
Just an observation. The questions are not for you. The questions are for us, as scholars and researchers, to reflect. So each one says, if I were to stand up and do the same study in my province, would I stand up with these questions? I think that should be the spirit. So it's not for him, it's for us. Yes.
Thanks, this is not just for the suggestions, what I feel.
Okay.
Whenever we choose the model, drought model for the areas, study areas, I think colleagues also mentioned that choosing the study area, it must be the more or less same environment. For example, we choose some Chata and then Uppington, Johnbed. Uppington, and that is, as you mentioned, the Kalahari Formation is arid region.
Yeah.
But it's like a desert. This side, when you come, it's a semi-arid regions. So the model, what we need to do, the drought models, it's based on the environmental factor. You are collecting the long-term data, the historical data we collect, then we are going to compare. The drought usually with certain areas is based on the 5 years once or 3 years one, the drought, same like Cape Town, what happened.
Drought is always once in 5 years, but when it is extreme climate, in the 2018, the examples, the difference. So what when we run the model, better we can choose the same type of the environmental factors, like a more or less the at least rainfall precipitation, if it is the same level of the precipitation, it will be, I think, it's good. If you, because we can't compare the arid region, always drought there, you know. There in the Uppington is rainfall intensity is less than 300 in the Uppington area, because it's like a desert. When we come here in Tata, this area, this rainfall is more than 1,000 millimeters. So it's extreme end. This is there is the arid area we can't compare with the drought models, because always it's a drought, because the precipitation is very less, infiltration also is very less.
You know, the SPI here, we are predicting with the precipitation. That's what I didn't mention. The data we use in calculating the SPI is the precipitation data. Yes. So we didn't leave out precipitation in the model. Yes.
What is saying, normally with SPI, what they can call the long-term, but consider the normal rainfall. So it's calculates, it compares your normal to what you can call it
abnormal.
Abnormal. So it considers the local climate of the area.
What is the normal?
So hydrologically, it's a long-term rainfall. Previously, before the climate change issues, you would consider your 30-year average rainfall as your normal rainfall. But now, with climate change, I think the definition needs to be revised. Yeah, long-term average. But now, climate change is kind of changing, so the definition needs to be revised.
I think 20 years so is minimum is enough. Instead of getting out of that. The predictions, you know, how we are adjusting in the model.
Actually, I did not 30 years
back
for anything to mention climate.
30 years.
30 years standard. So whatever you want to predict must have a 30-year data to 50 to 200 years. But if you have below 30, 20, 30 years, the still feel is a more, it's called variability. Variation, climate variability. So it's not climate change. But once it's above 30 years now, we are not talking about climate change. So that's amazing. Yes.
Also the data, how it is available. That one also.
Thank you very much. I think this topic is quite interesting that we can debate and debate. There's one burning question, I think, at the back there, so I don't look like overlooking it. But if you look at this slide, for those of us still studying, I think this is the best slide in this present. It takes you from different countries before you choose your method. Don't listen to your professors and supervisors telling you your method should be informed by readability. So you see the models, different models in different countries, and that should be the basis of which one to choose. Yes, good. Finish it up. You have your hand up. I don't want to ignore you.
It's not a question. I wanted to just say, perhaps there might be data supporting the evidence field that on the far west, close to the ocean, there seems to be a bit of more rainfall there. I'm reflecting on your response when you mentioned that proximity to the ocean might influence what we're observing. Because normally, the 5 times I've traveled to Swakopmund from Namibia, I always get rain on in the far end by the ocean side, but inland it's far too dry. Though there's those big events of one-off flood, but then quickly those rivers they dry up but in the end, the far edge, more often you get a bit of rain, not a lot of rain, but every evening then some. So it could be those things that we want to view in terms of the difference between
good observation goes into field observation.
Yeah.
So I think the next level stage we'll do more about ground truth. We need to find out what is the reality that will compare with the modeling. The modeling is good, but what is happening actually on the ground also need to be considered.
Yeah, maybe in the next one, like I showed in the map, here now, we look at the whole country as a single entity. Like I said, what parameter that may affect the drought situation in, for instance, in KZN here, will not be the same. So we look at it, okay, say this is how it is in a whole, and then we put it up, interpolate it in a map, and we see it as a single file. And then also we can do that, use something like the SCM, long short-term memory, to maybe run a short prediction, maybe for 5 years, and see, okay, this is how it will look like based on this data we have in the next 5 years. I think that will give us also a more vivid picture.
Thank you, Dr. Emeka.
Okay.
Let's have our own honorable here. So our next presentation is by Dr. Ramesh. Yeah, over to you. As he's putting up his slide, don't worry about it. We don't want problems. So a small problem for us is an urgent problem. So we'll make sure that everyone in the world knows we have a problem, because we're looking for solutions.
Thank you, Prof. I would like to welcome everyone again. It's not well. I've already minimized. To minimize that. I apologize for the disruption. I would like to welcome everyone to day 2 of the workshop. I am Dr. Rakesh Roshan Gantayat. I'm a postdoctoral fellow here. And I'll be discussing regarding the assessment we have done in Berg River and its estuary. And the perspective will be for inorganic and microbial contaminants. So before moving into the study, I would like to give some overview regarding the river basin first. So the basin extends up to 8,000 square kilometers, and the river is 294 kilometers long, starting from Berg River Dam, as we can see there, Berg River Dam, to discharging all the water into the Atlantic Ocean at St. Helena Bay. There are various urban settlements all over the catchment, and some of the major towns include Pal, Wellington, Stellenbosch, Herman, Morrisburg, etc. The climate is Mediterranean climate with 200 mm annual average rainfall, and which is considered under semi-arid climate. There is a lot of agricultural activity on the river basin, and that might extend above 4,000 square kilometers. There's two major dams and a check dam on the river, particularly. The biggest dam is the Berg River Dam that was built in 2007, as mentioned by Professor yesterday, which controls 33% of the annual rainfall, annual runoff from the sub-catchments on the upper stream in this region. Then the other two dams are minor, but the reservoir supplies a lot of water towards the agricultural activity that has been going on in the river basin. Additionally, Berg River Dam is a major supplier of water to the Cape Town municipality, along with the redistribution of this water all over the basin and the other reservoirs for their agricultural activities, which is very widespread. I'll move into the estuary. The estuary is a bar-built estuary with a high tide access, which means the bar doesn't allow the seawater to enter generally unless it's a high tide. Along with that, the flushing out also is obstructed by the same bar feature at the river mouth. Tidal height from the Atlantic Ocean ranges from 4 to 5 meters. And the estuary is particularly dominated by aquaculture activity. But major flushing happens in this estuary during winter rains, particularly in this basin, which has been reduced over the years after the construction of Berg Dam, and which mainly control the flushing out in winter rains. Lithological details. The whole basin is mainly consists of three formations: Malmesbury Formation, Cape Granites, and Table Mountain Group. Malmesbury Formation covers around 5,640 kilometers approximately. Major rock types are shell, limestone, and grey wakes. This is the epicenter in the river basin for the land use and recreational activities here. Majority of the urban settlements are here. Majority of the agricultural fields are here. Some of the previous studies have shown the EC value in the groundwater in this particular formation ranged up to 6,000, and some of them are reported also from 1,500 to 5,000 US per cm. For the Cape Granites, that's nearly at the estuarine zone, we can say, but at the lower region of the river, it's dominated by the Cape Granites, which mainly made of clastic phyllites and granites, approximately covers up to 1,477 kilometers, square kilometers. Then comes the Table Mountain Group, which are made of sandstones, but the high altitude and steep slope generally contributes to the runoff, but not much of weathering or erosion can be expected from this part. Methodology that has been adopted for the study, considering 32 water samples that was collected starting from the Berg Dam to the river mouth at St. Helena Bay. So we have considered major ions and nutrients that was analyzed through ion chromatograph, and some of the trace metals, as you can see, and microbes such as E. coli and HPC and total coliforms. So the data processing was mainly done through SPSS, and some of the GIS tools such as QGIS using Copernicus DEMs and terrain profiling tools were utilized. Cluster analysis was done through Orange machine learning tools along with SPSS, and Microsoft Excel was utilized to generate the graphs. Health risk assessment was done using the average daily doses and hazard quotient, along with irrigational suitability indices were used. So first, to study the river completely and draw the whole picture, we segregated the area into two zones. First, the estuarine zone and the riverine zone. So the delineation was done primarily based on the SMI values. But when the SMI values were plotted, as we can see in this graph itself, there is a lot of samples, around 14 samples fell above the value of seawater mixing. So with those confusion, with that creating a confusion, it's a highly undulating terrain in the river basin. So the terrain profiling was utilized starting from the river mouth towards the upstream, where around 70 to 75 kilometers distance, there was an elevation of 5 meters was noted, and comparing the tidal height to 4 to 5 meters, it was it's not imminent that the water will pass beyond this point. So depending on those categories, the estuarine zone was plotted up to 70 to 75%, and the elevation, as I noticed, it was 5 meters with a slope of 2.94 degrees and a distance of approximately 300 meters. So the high SMI values and the ionic ratios beyond the estuarine zone stipulates towards a different source of salt, particularly in this river water. So even in these graphs, we can notice there are some of them falling in the mixed zone along with the seawater zone. In the other indices also, there is a mixed behavior of all these samples along with the estuarine samples. So we focused on the controlling mechanisms. So major water type was found NaCl in the river along with the estuary. The estuarine samples fell particularly in the evaporation zone, where the river samples fell in the mixed mechanism zone that works with rock water interaction along with the evaporation. Similarly, another ionic indices also suggested the same thing. Some of the river samples also indicating the evaporation dominance in the region. Along with reverse ion exchange was dominant along with ion exchange, the estuary and the river. Some of the sources, the mineral dissolution were found were silicate dissolution, calcite, gypsum, were the dominant minerals that have been dissoluting in the river basin. So in case of nutrients, nitrate was found dominant, and ammonium and phosphate was falling next to them. So when we put it into the cluster analysis, it was noted that nitrate was falling together with all the major cations, that has been indicating that the salt leaching from or the salt source or seawater source in the river basin particularly, which indicating some of the previous studies have indicated there is a synthetic deposition of salt. Along with there is a synthetic deposition of NO3 because of the semi-arid climate in the region, which doesn't rain all the time, but in case of winter or summer, there is heavy rain, which washes away all these synthetic deposits towards the river through the tributaries. So there's some of the study here. One of the previous study has measured that the synthetic deposition of salt in the regoliths, particularly in Mal-Masbury formation, is around 200 tons of salt per hectare. So these nutrients such as nitrate is particularly combining with these major ions in case of because of the agricultural widespread agricultural activity that is going on in the river basin to form the erosion. In case of microbial studies, we noticed there were various zones were noticed when we compared the total coliform with the nitrates particularly. Some of the samples represented high coliform intake because of the high coliform intake of nutrients particularly, and there is a increased agricultural activity zones. The absorption of these nutrients particularly happened by the sediments, but the main zone was the increased domestic sewage zone. This zone particularly fell in the region where there is lot of domestic sewage or a stagnant water condition that has been found in the river because of the check dams or the reservoir in this part and this part, but this part was dominated by domestic sewage because of the towns that has been existing there, the Wellington and Pal urban settlements. To segregate the processes in the river and the estuary, the data was segregated into two groups and projected into the statistical factoring. So in the statistical factoring, we found various major processes that consist of total explaining around 86% of the variance, where salt leaching and deposition under the seawater resistance, particularly salt leaching, was noted here, which was in the negative, which fell in the negative variance, and the deposition was suggested here in the positive variance. Along with that, another factor was controlled by the microbial activity, as I have explained before. That fell into the domestic sewage category or the stagnant water condition, which has been noted in these stations particularly, which has been highlighted in the previous slide. Then the silicate weathering was dominant, along with the erosion of trace metals such as Fe and Mn, along with cobalt and copper. Then another factor considered the agricultural inputs particularly, where it's dominated with fluoride. That's particularly the part of phosphate fertilizers, along with lead. That has been also part of the fertilizers, phosphate fertilizers. Similarly, in case the same statistical factoring was applied to the estuarine zone, and it was confirmed before that it is a high residence zone of the freshwater and the saltwater mix zone, where because of the low flow of the river and some of the processes that has been going on there, mainly by the absorption of cobalt and lead, particularly the deposited ones by FeMn hydroxides in this zone. Along with there is action of humic absorption under the seawater influence of copper and phosphate in the lower zone of the estuary. And there has been a lot of activities of aquaculture that has been also dominating towards the high concentration of fluoride, particularly in the estuarine zone, along with the seawater. So some of the comparisons were done to the studies that has been done in before around 2007 or before the construction of the Berg Dam in the upper region. And the data indicate that there has been an 8-fold increase in nitrate twofold increase in ammonia and threefold increase in phosphate, particularly since 2007. Before the Berg Dam construction, the contribution of those three sub-basins were around 33%, and some of the studies have also confirmed that estuary is getting 30% less freshwater input in last 10 or 13 years. So this clearly indicates that the lower region after the Berg Dam has been very active in case of contributing these contaminants to the river because of the freshwater flushing from the upstream region. And those has been getting deposited in the estuarine zone. And because of the high residence time, estuary resulting in high evaporation and deposition of these contaminants. Okay. So considering the water quality, river water quality was found unsuitable for drinking because of the high microbial concentration and along with some of the major ions and trace metals. 70% of the stations were found unsuitable for irrigational activities as well, and they pose a threat of high salinity and low permeability of the soil. Health risk assessment, fluoride, in case of fluoride particularly, it was found high, and fluoride ingestion risk was limited to estuarine zone. But in case of estuarine zone, it's a saltwater zone, so drinking water is predominantly less. But fluoride, in case of dermal risk, was widespread in the riverine region for adults, children, and infants, which might lead to the dental and skeletal fluorosis in future. In terms of metals, there was no risk involved in those in the water samples, particularly. Limitations of the study. The study has only considered some of the water samples, where to confirm some of the observations that the bedload sediments of the river and estuarine data is required, along with some of the seasonal studies of the contaminants in case of deposition to confirm the synthetic deposits of the salt and agricultural inputs such as nitrate and phosphate needs to be further investigated. So this is where I'll conclude my presentation.
Good presentations. Let's engage with the presenter for the coming 5 minutes, but less than 10 minutes. First question, I can see from Prof. Silva.
Go ahead. Sorry, estuarine zone.
Yeah.
How do you define that? What are the limitations? How far does it go?
It goes up to 70 to 75 kilometers.
And by what factors do you determine the limits on?
By the terrain profiling with the DEM tool, I try to draw a line along the river bank and to the upstream, and it segregates the line to 70 to 75 kilometers, particularly in that zone that has been elevated up to 5 meters.
Okay, the classical definition of the estuary is one that you can take the estuarine, the upper limits of the estuary to be the zone where you've got your sulfur intrusion.
Yes. Yes.
Are you using those definitions or are you using a different?
No, we used the saltwater mixing index first. That will indicate the seawater saltwater zone completely, but
Okay.
that has been extending up to 14 samples points.
Okay.
That extends up to 150 kilometers.
Okay.
So looking at the terrain, the tidal water will not pass this elevation, and there is a lot of check dams on the way, according to the field observation.
Okay, no, that's fine. So I'm just making this comment just for noting that in terms of the Department of Water and Sanitation, and in terms of the definition of an estuary in the ecological sense, that is the 5 meter contour line.
Okay.
Okay. So the 5 meter contour around the estuary, okay, going along the river, okay, is where your definition of the ecological zone, the estuarine functional zone as it is known. Okay. And typically that is what is used in consulting purposes when developments occur adjacent to an estuary. So this is one of the things that you need to consider, and because not just for water, it's water for not just for people, it's for all the organisms that depend on it as well. Just a point of view.
Yeah. Thank you, Prof.
Yeah, my question is that you concentrate on the one big bag river. So how does it able to apply for other dams in KZN, for example? Then my follow-up question is that, you saw my presentation, which we did on the floods in 2022. What my impression is that, for example, before the flood occurs, what was happening in the land, and what are the quantitative measurements or what we can do with that water. And then after the flood occurs, then we can check that to see the contamination, whatever happened during the flood, and then compare the results between the two and to give some kind of awareness, to see due to this flood, this is what happened. Is that possible? So I'm looking at, since the flood is on Durban region, I'm looking at Ambeni Dam, for example. That would be interesting for me to look at.
For your first question, the study is based on the river basin features particularly, and the observation in the field that formed of this concept completely. But if you want to compare another river basin with the same thing, then we have to look at the terrain, we have to look at the activities that has been going on there. Then only we can form up a concept that what is going on there. Regarding your second question, I think yes, it's possible to do a study before and after to compare what's going on after the flood.
Okay, so Prof is more of a replicability of the study. If we're going to transfer this study from Western Cape, and they go to KwaZulu-Natal, how useful will the results inform our papers here, and how applicable in the other setting sort of scenarios.
In case of geochemical analysis, I think it will be same. It won't be very different. But in case of terrain features, if you are utilizing, like I have utilized the terrain profiling tool, that will be different. In the case of this river, we have, in case of geochemical analysis or human risk assessment or the water quality, I think the studies can be the same. It can be done in the same way.
Continuation of the. We didn't show that table, comparison table.
Oh no, I did not. That is too much.
The same in your bed river, we compare with other national rivers like the Wall River and the Orange River. Also all over other different countries like Australia, Poland, and something. How the differences, but we choose the river is the same environmental conditions. Like a semi-arid region environmental condition, we choose, then that comparative table may be further. But this is for just baseline studies. But I think that one also what you mentioned when you were studying the Liberian, it's more interesting after and flood and before flood. But
so I actually remember the table, but it's too big to keep in a slide. Yeah, but it's I think will be added in the manuscript. That it's a lot big table.
This was almost
Thank you. Okay, good.
Thank you, Prof.
My question still goes on the same first presentation. When this study was conceived, I am sure there was a problem that was identified, and you go out to do this study, get the findings to address that problem. In this context, what was the research question? Or what are the research problems that we are trying to address here with these results?
First, there has been a lot of studies before on the river, particularly, but geochemical studies, particularly what indices we have used and what kind of quality we have checked. There have been reports, not been a proper publication considering the chemical processes in the river that has been particularly going on. And to answer another question of yours, the study was actually conducted in 2019. And the data was collected and all these, the concept was formed. But in case of chemical studies, most of the data we have shown, it's been missing in a lot of publications before. But there has been a lot of reports on the status of water, the river and estuary particularly.
Not a problem. With this slide, I'm interested in this one.
Yes.
Whether it is findings or assumption where say river water was found unsuitable.
Yes.
For drinking purposes.
Yes.
What was the assumption? The assumption that we drink from river water. Why was this statement made in this context?
Okay. So in this context, when the contaminants are present, we are not suggesting you drink it directly from water. But if we are treating the water, you have to take care of all these parameters, such as the microbial parameters we have considered, E. coli and total coliform. These can cause a lot of diseases with continuous exposure, along with the drinking and other ions we have. They have also various implications with long-term drinking purposes. So if the river water is getting utilized in case of municipality, and these factors should be considered before just providing it for the drinking purposes.
I think an extension of that could be to compare it to the aquatic standards requirements.
No, it has been done. That's how the
Okay, then it's fine.
Yeah.
Because then
it has been compared to.
You're looking at the water.
No, my questioning was, it's not for him, I think it's for everyone. I remember 2018, I did ask the similar question, Jobe, the very big audience, when a student from one of the universities found out in her study that the rain was falling from the sky. So that was the finding of the study. So in conclusion, the study found out that the rain was falling from the sky. So I said, Madam, I need a clarification. I'm not a rain expert. Before doing the study, where will the rain come from? Do you expect the rain to come from the soil going up or up down? Before the study, because this is the finding. Now this one is the finding. It was found that the river water was unsuitable. Now, if you go to a bigger audience, everyone gathered there, which river water is suitable for drinking? Do we have findings from other river waters which has been found suitable for drinking, so that we say, this is a new finding. So we are surprised that in this river, this water is unsuitable for drinking. But from other rivers, it is suitable. That's what my sort of asking. So I'm saying it's a little bit an outlier. I think that's the point. It's an observation, but it's a good study. Let's give them.
I see. Back to some of the questions you were asking, that what were the objectives, I was thinking as well that you probably project into the geochemical evolution over time, either from the height or going to the future. So I think it could be an addition.
It's an addition. It's one addition to the old data. That's why we compared. Okay, what has been happened before, and we compare the same data, we can see the fluctuation that has been happening. And I explained some of the process that has been responsible for it.
So what is the implication going forward to the future?
What is the implication in case of action?
Yeah, action. What is likely going to happen in another 10 years or 50 years?
Okay. See, this is not a prediction study, but I have showed the limitations of the study that can be improved here. That we need the bedload sediments to check how this process has been happening, and we also need to check the deposition of these contaminants because in the agricultural lands. So without doing these studies and rest of the data that can be generated later to add on to do some prediction. But this is not a prediction study. This is status.
Yeah.
This is the current status.
Exploratory study feeding what is coming.
Yes.
Sorry, just I see your point about the conceptualizing of the project and so on, and the point you make about the study found that the water was unsuitable, suitable for drinking. But there are rivers where the water is so pure that it is suitable for drinking. And these are in the mountainous areas, particularly in the Himalayas, and studies have been done to show that they are of a standard that you can just take the water and drink it, basically.
No, I was just thinking. I thought from Big River up, that water is quite deep, and then below the dam is. Yes, but that was good. Let's go.
Actually, any research related to the pollution aspect, you will consider the two scenarios. One scenario, current situations, how the pollution factors is influencing in the different aspects. Another one is a future scenario. The future is a prediction. The future scenario, we have developed some model, or we need to compare with the historical data as we all drought model something. But this research we focused on current scenario because we collected only one season of samples. That sample is analyzed. Based on that results, what happened in that area. Whether it's suitable, what type of pollution, what is it? Because pollution is unpredictable. Today, the pollution maybe it's different sources. After 10 years, the pollution may be coming under different sources. The pollution is not constant. The sources of identification may be the common things, natural, anthropogenic, two things, that's all. The natural is permanent solution, but anthropogenic solutions is not constant. Today may be the industrial aspect, tomorrow may be agricultural influence. So this result, based on at present, based on the collection of the sample 2019, as he mentioned, 70 kilometers, the backwater influences. River water, sea water is went back towards that one also. When he mentioned that time we collected, based on that values. Maybe the river flow, when it is more, the flushing out, maybe it will be maybe 15 kilometers. If it is heavy flooded, 0. So these fluctuations is different. But these all the baseline studies, still we need to go for that. All the research is monitoring, it's a periodic. There is no end for the research. Yes, thank you.
Very good. Let's give a minute. Next presenter, this is not to scare the next presenters. The last one, the coming up is a very good research. Next presenter. Oh, properly. I was looking this side. Properly. You are the next.
I think it's there.
Yeah.
Okay, good morning, ladies and gentlemen. And this is my original title, but it's academic.
Not shared yet.
Not shared.
Yeah. So.
Yeah, this one. Okay.
Sorry.
Okay, thank you. So this is my original title. It's an academic presentation, but after discussion with Vetri, I would like to change it because we have too many academic presentations. So I would like to talk about my city, my university, my school, and my team. So it's not an academic presentation. I noticed maybe some of you will visit China next year. So when you visit China, visit my city, visit my university, I would like to show something basic to you. So this is the location of the city. You know the map, I showed this map yesterday. The blue one is the province, my province is Shanxi province. And you see the left map, the green in the middle is green. The greenish area is Guangzhou Plain. Guangzhou Plain is a big plain, And in the center of the plain is the Xi'an city, my city. So Xi'an has a long history, over 3,000 years. And it was the capital city of 13 dynasties. So it has a long history. Vetri went there twice, and I thought he has visited some historical areas, but there are many historical areas there. You have to spend at least 2 weeks to cover all these historical areas. It's okay. It's okay. Yeah, okay, it's okay. And here I showed some pictures from for the city of Xi'an, and you can see during the past several years, Xi'an has developed very fast. It looks like an international city. It's not that international compared to Shanghai, Beijing, but it is the most international in northwest China, and it's a hot tourist attraction city. So after pandemic, lots of tourists come to Xi'an and visit Xi'an. So it's very crowded in Xi'an last year. Yeah, it's very crowded. You see the lights, the left, the right lower, the flights is okay. Top one. This one. This one is very close to my university. At night, it's very it's very beautiful, and everyone come to Xi'an will visit this place. And I remember I brought Reggie there, but at that time it's not that beautiful as it is now. So now it's more beautiful. Yeah. So we have lots of such tourist attraction areas in Xi'an. And about my university, you know, in China, we have thousands of universities, lots of universities, but only 100 belong to the Ministry of Education. So my university is one of them. And in my university, in 2000, 3 universities merged together to form the new China University. But before 2000, there are 3 universities built in the early 1950s. So 2021 is the 70th anniversary of my university. Because in 2000, the 3 universities merged together to form the new China University. We have 3 main disciplines. One is the earth science. It's my school belongs to the earth science, and the other one is the transportation. Transportation is another one. The last one is the architecture. So 3 main disciplines in my university. And my university is covers 250 hectares. So we have 2 campuses, 2 main campuses. And in the center of the city is the old campus. We were merged in 2000. So we have 3 old campuses, but the old campuses are very small, very small. We have a new campus in the north of Xi'an. It's big. We now have 25,000 undergraduates and 10,000 masters and doctor candidates, and 1,700 international students. So my university can accept international students. This is what I want to say. International students coming to my university or even other university in China, they do not have to pay the tuition fee because they can apply for the scholarship. The Chinese government, the local provincial government, the city government, they have funding for international students. The purpose of this funding is to set up close collaboration with international countries. So if students come from other overseas students, they do not have to pay tuition fee. They do not have to pay the accommodation. I think that these are covered by the governments. Here I showed some pictures of my university. The left right, the left up, so the geological building. This is my campus. I lived in this campus. It's small, but very, very quiet. And the right one is the library at the new campus. It was put into use in 2003. Here we have 2 lakes within the new campus. So the beautiful scenery there. Yeah. So in winter, we have snows. Maybe some of you have never seen snows, but here in Xi'an, it's very common. It's very common. Yeah. And also in winter, it's cold, really cold. Today when I came here, I hear the guy, the female at the gate says yesterday is cold. I would not agree. I would not agree. It's not cold. Yeah. In Xi'an, in winter, it's really cold. Really cold. And in summer, it's hot. 43. Okay. Hot. Really hot. So in summer, really hot. In winter, really cold. But in other seasons, that's okay. That's okay. So if you come to China, come to Xi'an, do not come in August. Do not come in January and February. January, February is winter, it's cold. And July, August is summer, is hot. So in other months, it's okay. Here, schools and colleges means I see in your university it's called faculty. Yeah, faculty. So we have 5 schools and colleges. And my school is School of Water and Environment. This is a new name. It was changed from School of Environmental Science and Engineering in 2019. So last 2 times I came here, I introduced my school. It was School of Environmental Science and Engineering. Now in 2019, the school name changed to School of Water and Environment because in my school, we have 2 main disciplines. One is the water resources. The other is environmental science. The previous name cannot cover both disciplines. So we changed the name. And we have lots of centers, teaching centers, library, international joint library. We have lots of it. So you can see we have 91 provincial and ministerial level key research bases. We have lots of bases for research. And now we have 3,000 full-time faculties, and including 4 academicians, and 1,400 are full professors and associate professors. So the faculty there are generally a high level. We also run some academic journals, but these journals mostly are published in Chinese, except the Journal of Traffic and Transportation Engineering. This is the new journal set up 2020, around 2020. It was published by elsewhere, so it will be covered by ICI very soon. So this we have a lot of international students since 1956. Till now, nearly 4,000 international students from 70 countries have graduated and gained their master or PhD degrees. We now at present have 1,700 international students. So more will come in the future. This is the school, about the school, the history of my school. You can see from the map. Previously, this school was merged from schools from all the 3 universities. So, you know, China University is merged in 2000 from 3 universities, and different disciplines from the 3 universities formed formed my school. So we have different disciplines. It's very complex. We have different disciplines, and these disciplines how to say, compete with each other. They need to get funding, and they compete with each other. And you can see in 2019, the name was changed. But in my school, water resources is the most powerful discipline. Yeah. So even environmental science, this discipline depends on the water resources. So all the research from the environmental science, it depends on water, wastewater treatment, groundwater contamination, remediation. So all this research work depends on the water. So we have 4 departments: groundwater science and engineering, hydrology and water resources, environmental science and engineering, and also chemical engineering. So the first two departments are very powerful. And environmental science is okay. It's okay, but not as powerful as water resources and the groundwater science. At my school, we have 120 full-time faculties and 27 management staff. So the total number is 147 at my school. And among the full-time faculty members, 28 are professors, 47 are associate professors. And they have received numerous honors and distinctions. Among them, one is the Chinese Academy of Engineering, academician of Chinese Academy of Engineering, and one is a young outstanding scientist of the central government. The second one, the latter one, it was me. So I guess I have contributed a lot to the school, to the development of the school. This is the academician at my school. He is old, almost 90, almost 90. So I hope I can be the next academician. You see,
The next old one.
Yeah, you see, his name is Li Pei. Yeah, Professor Li. So I hope I can be next Li. So this at least some libraries at my school. At least only 5. Actually, we have 11. We have 11 libraries. All these libraries provide platform for teachers and students to carry out their research. There are experimental centers. These are the centers for the undergraduates. They do their experiments in these centers. Yes, we also have a in situ testing field. This is unique in all Chinese universities. In other universities, you cannot see this because my new campus is very big. So the president, we call it president, the president allow us to set up this in situ testing field. So in other universities, you cannot see this. So all this, all the research can be carried out in situ on this testing field. We also have a rainfall modeling hall. It's a very tall to model the precipitation. But now I guess this hall is not in use because running a big hall requires a lot of money to maintain it. I guess this hall is not in use now. Yeah, during past several years, I have published lots of papers and some of them are highly cited papers. And I contributed, and my team contributed over 30 highly cited papers. My school has 70 highly cited papers, and my team contributed 30. So these guys, they have highly cited papers. Professor Gao, she has. Also, we have published some books, but all these books were published in Chinese. So this year, Vetri and I are trying to publish more English books. So we are trying to do this. And yeah, the faculty at my school received some national awards because they have done a lot of good scientific research. Yeah, these are the certificates. You can see this minister of the land resources. I received a award, and he gave the certificate to me. And the Nature, I published a piece of article in Nature. So it's the first Nature article in my university, in the history of my university. And we have organized lots of national and international conferences, and we wish to organize more in the following 3 to 5 years. And we can collaborate to organize some high impacting international conferences. Yeah, this is some photos for the conferences. You see, I think in
That's changed.
yeah, time changed. Each year, I always invite some international scholars to visit my university. So these guys are from Canada, US, and also Vetri are here, Vetri and his students. So next year, you should plan. And we have some fundings from the central government. This year and next year, I can cover the flights and accommodation. So if you have plan, do plan for that.
In winter.
Yeah. In winter, actually, in winter is okay. In winter is okay. Yeah. Even in winter, inside is warm because we have heaters there. But outside, if you can wear a jacket, that's okay. It's okay. And this is about my school. And now it's about my team. My team is a big team. It's a big team. The person in the right is my supervisor. We work together for many years. You see, Gao, Professor Gao and I have the same supervisor. That's why I brought her here.
Also your wife.
Yeah. The lower left is my wife. Yeah, the blue background. Yeah, Dr. Jianhua Wu. She's my wife. And then these guys and females, they are my team members. I think Vetri, you can recognize the second one from right.
Yeah.
He is my PhD student. He graduated this year and will stay in the university as a teacher. So these PhD students, I have lots of PhD students. How many? 17. I graduated some PhD students had graduated, but these students are now studying. So we I have 17 PhD students, and 5 of them are from international. They are international students. And these students, if they work hard, I believe they can get a lot of achievements. Yeah, that's this PhD students, and here the master and the undergraduate students. You can see most of my students are female. So I'm trying to have more boys because our discipline we need to go field work, and it's more convenient if we have more boys. Yeah. Yeah, this some pictures showed the first visit to the University of Zululand in 2018. That's 2018. I visited the lab and the library, and we meet and discuss with the vice chancellor. We also go field with battery to collect some water samples. That's 2018. It was my first time to be here. At that time, I was very excited. It's a new environment, new experience for me. So I was very excited. And this is the second visit to University of Zululand. So as I said, the second time I feel familiar with the people, country here. And the second time I brought my supervisor, my 2 students, and 1 colleague here. And that's their first time be here. So my supervisor was very excited. Yes, this is the first visit to China. Vetri, and 3 students went to China in 2018. And I guess the students, they enjoyed it there. I take them to some visiting tourist visiting areas. I think they like it. And 3 days ago, I met Chriso, and she can even speak 你好. Yeah, she still remembers the word.
Yeah.
Yeah, this is also the first visit to Chang'an University. We have a geological museum, so we visit. This is the second visit to my university. At that time, I guess I remember Vetri went there to attend a conference, right? To attend the conference, but I took the students to another province. We do some field work, collect the water samples. But after that, I brought them to some tourist attractions. You see, you do in the middle, it's a wedding. It's a wedding equipment. Yeah. So I asked Danisha to sit in just like a wedding ceremony. And the right one, the lower right one, is the last day. We were in another province. We in another province, so we eat hot pot. I don't know if you have tried hot pot. So it's very famous in China. But I guess, Professor, you never had it.
Chicken feet.
So next time you visit China, you should try the hot pot. It's very popular all over China. So this is my report today. So I look forward to collaborate with all of you. Okay. Thank you.
So this is our last presentation of the session. But please, you need to engage. Let's engage with the presenter. Yes, sir. You understand?
Lee, who is a close friend of me.
Yeah.
Colleagues, I really feel very proud to standing with such one of the topmost researcher in the world, in particularly in the groundwater, also in the #1 researcher in China. If he's looks small, is normal person, but his research is very big. I'm standing with a big person. He's but his his citation is more than 14,000. I think I don't know when we are going to reach in that level. It's really he published in the Nature. He mentioned that he's the first person published in Nature. Nature. If you publish one paper in Nature, you are topmost researcher in the. I think no one is here. Maybe in the Nature publications. Okay. I don't think he mentioned that. That's what I'm telling. He's very humble and normal, but he's very big person, big professor. We are standing with him. That's what I feel personally very proud of. He's a good friend of me. Also, we had a long relationship. Only as we always discussing, we both, as we all like tools, we can create only the opportunities. We all we can create who is going to utilize opportunities? You all try to utilize opportunities. As he mentioned, out of fundings, invitation, that invitation is not for me, for you all. What he is mentioned that free. See how many students we visited in that. I totally forgot those pictures, beautiful memories. Now I recall. See, my university is a comprehensive university, it's a black university. I want to take my kids into the different environment. I want to, as a professor, I want to show the different life. But unfortunately, last 3 years, due to the COVID, I can't send my students. Otherwise, all my students, the first experience, when they excited, the new life, you understand that. These all the opportunities we creating. But if you all really good, definitely next year, what he mentioned, I'm sending 5 students to China with the free of cost. But exactly, I'm not joking. I have the potential, all the facilities, everything, but I'm looking the good students. That is the question here. I can't send just like that. I'm looking the good students. Good means not the hardworking students. You understand that? If you are well hardworking persons, next year, definitely I'm sending 5 students. 5 students should be in China University, maybe for 2 weeks or a month for the training. That's what I would like to announce. Thank you.
Wise ways and the encouragement. So do encourage and spread the news to your neighbors. I think this is the end of our first session. We can take a quick break. And how many minutes? Maybe 30 minutes will be okay. Let's come back in 30 minutes so that we speed up. Thank you so much, colleagues, and enjoy your team. You can upload whatever lecture. I think it is side. Okay. Yeah, you can do it.
Where is it? This one. Passport. No, it's yours in all detail. Where is that folder? Yeah, which list it?
Just like this one.
Yeah.
The outline will
Okay.
Will be lunch break most probably around 1:30. Yeah, every public transport was and which means to verify that
Thank you. Hello, everyone. This is Dr. Tasfaye Bintamo. I'm here today to present this workshop. The first of all, it's my privilege to be with my professor, supervisor, Professor Kanerere. And I'm here in this topic of using open source geospatial data set for water resource assessment and management. So I tried to concept this idea in 2 weeks' time. Then after that, I tried to develop some ideas. Before that, maybe we answer some questions from previous one, and just to overview my previous work as well. I will show you, and you will appreciate again about the GIS and the remote sensing techniques application in water resources and assessment and the management. So let me go briefly. This is one of my PhD research publication on climate change impact on groundwater quality. This one is a complex project, but we try to manage it in a GIS framework to visualize like this. This publication in 2021, and so far, I think 13 citations already done for this publication. So this we can see how the climate variables and all the affect the groundwater vulnerability or contamination risk. So that was the validation with using the point source laboratory analysis result water quality and the correlation of that. The next, as Prof said yesterday, I use a modified drastic model for, again, groundwater vulnerability risk in urban hydrological context in a coastal area aquifers. This one is also another important insights. If we can see, these are parameters for drastic. I modified it, as I said yesterday, including the land use change parameter for this study. So we can see the vulnerable area, how much area covered with high risk of vulnerability, moderate and low and poor areas. Those are the water quality parameters index map. Then we correlate, it's really correlate to each other. We appreciate that from GIS work in the remote sensing as a source of data. The other important application of this GIS as a source in the remote sensing for groundwater potential evaluation as an assessment of the water resources. This one is also published, and so far more than 37 citations there. You see, these are the hydrological parameters. So how we integrate in a GIS platform used to analyze and come to the potential area for the zoning map. Still, we appreciate this from the GIS and the remote sensing works. So when we come to this topic that about the use of open data sources for the water resource assessment, is used for the water resource management, but the water resource management is, because of the increasing demand, is faced a challenge agriculture, industrial, and the urban development, in addition to climate change posing a risk that is known. But the problem is not only one parameters, but different parameters in different environmental, different geological, different land setting situations contribute that risk. So how we organize that data for that, and how to manage the parameters, the source of data is important, because the relationship of land use, climate, and the water is so complex. There are limitations of data sources. So these days, the Earth observation online data, open sources are used as a data sources. In this, I used try to, as a case show, in Bangeni. This one is in a less than weeks, 2 weeks time, I developed this idea. So this area is again agriculturally in the urban demand areas need attention because of that potential vulnerability of water resources in this area. So the geospatial open data sources for water resource management is important. As I said, historical data for hydrological cycle, including for surface water and the groundwater, is important. All in hydrological cycle, all the climate variables. But so how to integrate in one platform to see with land-based activities. So that brings all the data. Also that the climate and the land use change, all data is data intensive, in both temporally and spatially. This managing of this data is also needs a skill and the methods for that. So this GIS platform from Earth observation data would help to address these problems, and most importantly, to visualize this data online or on web-based is important. For this study, I use the data sources from VAPOR. This is a FAO portal that monitor water productivity through open source accesses based on the remotely sensitive data. So I use that one as a case study. Also, the Global Land Data Assimilation System, GLDAS, from NASA through Google Earth engine. The tropical rainfall measuring missions also used. I use also the World Water Policy Support Model. This comes with data for analysis and visualization. These are the data sources for this study. So this is one of the actual evapotranspiration map for Africa in annual base, in the resolution of 250 meters. We can see how the actual evapotranspiration variations. It needs some process, but we appreciate we can get this evapotranspiration map from this. Specifically, when we see from this map in the Impangeni area for the year of 2021, the value of actual evapotranspiration is that, and we can point out this value for actual evapotranspiration of this specific area. Also, this is a land cover change. For this is for 2017. In 2017, the water coverage in this area is 40%, the trees 29%, and the built area is 6%, and the range areas 31%. So how this changes for 20 and 22? Let's see. So the land change range from 31 is decreased to the 25. The water body is the same, 14%, but the trees increased from 29 to 36%. The built area also increased from 6% to 7%. So we can analyze for land cover change from these maps of observations. Also, we can get the water productivity for agricultural purpose. We call this gross biomass water productivity. It will also help to get this analysis. And normal index or for water index, like vegetation index, we can calculate for monitor water content for agricultural purposes. Yes. So also, as I said, the spatial change of land cover changed in different times. So we specifically can see how the bare land changes, how the tree coverage change with. Also, that is the runoff area, so we can identify the high risk runoff points in that area. Even we can calculate the water balance. So the water balance maps from this. So sometimes the change in water balance is negative value. This indicates that the upstream source of water and the groundwater supported the recharge for that area. In the case of precipitation is, no, actual evapotranspirations are greater than precipitation. Yeah. So as a tool, this Earth observation on the open data source used to see all the data sources and the visualization in spatial and the temporal coverage. This is how changes in the prediction for the future. It was baseline for 2000 and predicted for 2041 to 2016. The difference is the actual rainfall is decreasing in a mean level. So this shows that the decreasing of the rainfall in the future, the near future. Yeah, this can also how we can see spatially in that area. This one is for the temperature. So how the temperature changes for example, in January, it was 24.84 degrees centigrade. In 2016, it will be 27 degrees centigrade of monthly temperature. Okay, you can see here the precipitation value, the urban setting, and the croplands. So how this contribute to the pollution or contamination risks. That's the risk index of the the vulnerability index of the pollution in that area. So for validation, I take some online data, maybe just for demonstration. I haven't analyzed or in detail of this verification of that EC value in this area, but it shows how we can verify or validate the results based on the existing actual water quality data, like electrical conductivity. Yeah, we can see this open source geospatial platform is used for visualization and the decision makers and the management. And then it's open web-based sources for water source assessment and the management. Thank you.
That was good. And yes, let's have comment, questions on the presentation.
That's a question of validation.
Yeah.
Because it's easy to mix in fact, in terms of you did a good job in terms of taking the remote sensing data, into GIS platform, where they collaborate together and to give a very visual for water management. But how do you validate what you have on ground? Because if you just look at this image, for example, if you look at the techniques behind this, the reading of which one was used there, the background techniques, the mathematical techniques behind it, or the maps, is it reading? You get what I'm saying?
Yes.
So there are lapses in there, and that's where ground truthing that we are talking about. It's very important, particularly if you are in a catchment here, So to me, I would suggest that with these, you also need some local tutorial or observed value, apart from the ones we pick up, particularly for landfill and for Landsat and for remote sensing data. You see, the challenge with remote sensing is, as good as they are, local factors plays a big role in what you end up having at the end over some time. Yeah, remote sensing will not tell you it is a sugarcane plant that is making the whole place to become looking so, it's a sugarcane plantation, But if you just give you, it's so green. No, it's so, but beyond that sugarcane, are they using fertilizers? Are they using what is the underground geology? That is allowing preferential flow of water. So those things like that. So also try to see how it can be included. It doesn't need to be included as part of the remote sensing and the GIS. It could be included as a model for validation. To just cross-check, what you have from the Victoria and what is available actually on ground, and that is a very, very clear picture that people will now relate to directly going forward. So it's a nice presentation.
Good. Any comment from the right? Yes, Doctor.
Yes, thanks for the presentation. I do think that the progress made in terms of open source, particularly air conservation, somehow does have the potential to address issues that are related to the measurement data and different components of the balance. Then the question is, most of the time we use that data ourselves, but we somehow have some technical geospatial analysis skills. How can we make use of these data sets to help communities like farmers who somehow need to know what the rainfall is coming or the trends in society and so on? Not only related to rainfall, but then other components related to water balance, which give them informed data for them to make informed decisions. So how can we bridge that gap using open source?
Yes, thank you so much. And that we can do that. The first, the mobile application in a web base, they can use the monitoring of their water resource. Now, these days, this citizen science, to collaborate all stakeholders in that watershed or specific area, it's just engaging in the training them and just participating on that, explaining all these results. Like I told you yesterday, I did this for water in the sanitation department in the Western Cape province. And also there is the field data collection apps right now is developing. So from local, you can get the data from the local community, the farmers, through mobile app. So I am also planning to report that one. But as we mentioned, this can help us to see all those stakeholders, all those parameters in one platform.
Awesome. Great. Let's give them a hand. So we have two presentations coming closer to on land use activities, and they also have more observations. But I think what is is emphasizing is that it is a very encouraged to work with these technologies, but we should not divorce ourselves into reality. So there is something happening on the ground in the catchment that we know, but what the conditions in the catchment, in the river, in the aquifers on the ground, sometimes they are not presented by the land side. So there's a data which has been captured by the satellites, which is a good science, but we should always remember to cross-check which activities are happening on the ground that may explain what we are seeing. Next presentation, Prof, please come up with the assessing background levels and the pollution sources of arsenic and fluoride in the different aquifer systems in the city of Chia. Over to you, Prof. You have a presentation.
Sorry, they are all in one folder. Take that. One of the folders is that one. Yes, you're in. Share green. Which one? Is that this one? Yes. Yes. Yeah. Share should be up now.
Okay. Okay.
Full screen. Yes. Over to you.
Hello, everyone. Today, my topic is assessing background levels and pollution sources of arsenic and fluoride in different aquifers of Xi'an City, China. The picture on the right is the respective of Xi'an City. It is Belltown. Outline is included this four parts. The first part is background. As we know, arsenic and fluoride are two of the highest priority contaminants in groundwater worldwide due to their toxic effect. When the concentrate of arsenic is higher than 10 microgram per liter, it will result a decline in intellectual function in children and increase in cardiovascular disease, lung, liver, and bladder cancer. And when fluoride is lower than 1.5 milligram per liter, it will strain our teeth and skeletal tissues. But when it is higher than 1.5 milligram, it will result in dental and skeletal fluorosis. Now let's see the arsenic distribution in the groundwater. Globally, 94 million to 220 million people are exposed into high arsenic concentration in groundwater, and 94% is in Asia. In China, arsenic contaminated groundwater was first recognized in 1960s. About 19.6 billion people are at risk of being affected by the consumption of ethnic contaminated groundwater. For Florida, there is about 108 million people are affected by the forest hazard worldwide, and mostly happened in Asia and Africa. In China, the high Florida contaminated groundwater has been reported in several provinces, such as Shanxi province, Gansu, Inner Mongolia, and Jilin province. Then how about the groundwater quality in Xi'an? The groundwater is usually used as a drinking and irrigation water source in Xi'an. As reported in the 1980s, the high concentration of arsenic and fluoride has up to 0.184 and 2.82 milligram per liter, respectively. It threatened the health of many of local residents. It so has a concentration of arsenic and fluoride. Then what? How they come from, and why happened this anomalies? Here we should identify the air contaminated with unusual high concentration of these toxic contaminants and separate the anomalies. This needs us to derive the nature background and then identify the outliers. And the next is to evaluate the human activity influence on the groundwater and assess the source of potential toxic elements. This needs us to assess the source of this pollution. This work is very important to ensure drinking water security. So the aim of our study is to include these three parts. The first is evaluate the nature background values and threshold values of groundwater samples in different aquifers. The second is to determine the areas of the threshold exceedance, namely the outliers. This we identified the outliers based on the result of TV. TV means the threshold values. The last is we need to assess the source of the potential toxic elements such as arsenic and fluoride in different aquifers. The second part is the study area and the methodology. As presented by Professor Li, Xi'an City is located in the inland center of China. With 13 dynasty history, it is an important birthplace of Chinese civilization and is the starting point of the ethnic Sikh rule. However, the field investigation have identified 14 ground issues in the urban area of Xi'an. In this, which one? Okay. I see this. The yellow line is the 14 ground fields, and additional there are 4 faults, namely the Wei River faults, Lintong, 2 Chang'an faults and Zhao River fault and Chan River fault. This it is showed in the graphic in red line. And the Linton Chang'an faults consists of 3 stacked faults. According to the geological and hydrogeological structures, the aquifers in the study area can be divided into phreatic aquifer and confined aquifer. The phreatic aquifer it exists between 13 to 8 meters deep and flowed from the Qinling Mountains to Wei River, the Wei River. And the confined aquifers occurs at depths greater than 100 meters. In our study, there are about 94 phreatic aquifers and 109 confined aquifers were collected in July. In order to ensure the occurrence of the geochemical data, low quality samples with exclude were removed before the calculation. We mainly consider that when the data ion balance exceed 5%, they will be removed. And if we don't know the aquifer type, they will remove. They will be removed. And for analysis values below the low limited detection, it means when it is smaller than LLD, it will replaced by 2/3 LLD. This is to ensure the data number. The methods to derive the nature background levels for identifying the abnormal elements concentration are quite different. And the methods of mean plus 2 times delta has been widely used, but this method is only with the recommendation of the dataset must be a normal distribution. However, the geochemical data rarely obey this distribution, but a skewed distribution. And the mean value and standard deviation are sensitive to examine values. This method is not very suitable for identifying the nature background by the geochemical data. So calculation of median plus 2 times MDA was suggested by Riemann to replace the mean plus 2 times delta, because it has a more robust method to handle the data outliers. But it should notice that the geochemical data commonly displayed strong right skewed distribution. And so the April 2 median plus 2 times MDA usually derived quite conservation. Because when we use this method, it is the underlying assumption is that the data set should obey a symmetrical data distribution. So this approach was correct when we use this method. We should correct this approach. Here we use the applied median plus 2 to 2 median plus 2 times MDA is based on the log transformed dataset and then back transform the result. In our study, we choose 3 methods to determine the nature background variables and TVs. The first is the median plus 2 plus or minus 2 times the MDA. The second is the TIF method, and the third is a percentile-based method. Part 3 is the results and the discussion. First is as we can see from the tables, arsenic and fluoride concentrations in the confined aquifers were higher than that in the phreatic aquifers. This means that these two elements may originate from the environmental geology or hydrogeology. However, the nitrate or nitrite concentrations were higher in the phreatic aquifers. This is perhaps in effect by human activities such as agriculture activities. From the tables, we can see that arsenic is higher in arsenic and fluoride is higher in the confined aquifer. And then we calculate the TVs of best methods. And the results was showed in the table 2. The results show that the median plus 2 times the MDA method may overset the upper concentration limited when calculate use a log transformed data set. And the TIF is based on the 17% plus a half times interquartile rate. It allows the definite of a storage for outliers even none is present in the dataset, so it is conservative. Here we should know that as arsenic and fluoride, nitrate and nitrate was toxicological indicators that might pose a risk for human health or environment. So they are indicator. When we identified the threshold values, we should depend on the ecotoxicological effect and their effects on the human health. So here we use the groundwater guideline values to identify the as the basic limit in assessed TVs. As we can see the graphic on the right, some are higher than, some are calculated TVs are higher than GGVs. That means a lot of the samples were beyond may result human health at risk. then we should use the minimum value to identify the TVs. Otherwise, the 1980% methods were used to equal to the TVs. After ensure the TVs, then we studied the spectral distribution of the outliners for arsenic in the free aquifers. The high content of the arsenic in the free aquifers were mainly caused in the southwest of Xi'an city with highly developed faults. And even though some fewer outliner is with lower concentrates, it is also around the Wei River faults and Chan River faults. And it is similar to the for the arsenic in the confined arsenic aquifer. For the fluoride in phreatic aquifer and confined aquifer, it is unlike the arsenic. Almost all the fluoride outliner were located near the river like Wei River and Zhao rivers. Meanwhile, the concentrated fluoride in the confined aquifers are higher than that in the free aquifers, and the outliner mean concerned around the Wei River faults. This indicates the effect of geology or geological structures for the confined aquifers. The third is we try to find out the source of arsenic and fluoride. As we can see the derived diagram, the hydrochemical types of groundwater with arsenic enrichment were sodium bicarbonate in confined aquifers and the calcium bicarbonate in the free aquifer, while the groundwater with fluoride animals, the types are the sodium bicarbonate in confined aquifers. And it is also quite differently in the phreatic aquifers. So we suppose the arsenic and the fluoride are from the volcanic glass, which is one of the main components of loess sediments. Then, if the main source of the arsenic and the fluoride is the interaction of groundwater and the loess sediments, it should logical to expect a strong position correlation between pH and arsenic, fluoride, and sodium, and a negative relationship with calcium. However, the results show that in the picture, we can see that there is a poor relations offset by arsenic or fluoride with other ions. That indicates that loess sediment has low effect, has very little effect on the high content and high content of arsenic and fluoride. And another possible source of arsenic and fluoride is the geothermal water because geothermal water is widely distributed in Xi'an, especially in the areas with highly developed faults. As the concentrate normally increased with depths. And in geothermal water, the arsenic ranged from 0.152 to 4.2 milligram per liter, and was very low in the ground with depths less than 200. Additionally, in geothermal field of Xi'an, the mineral ions was bicarbonate, sulfate, and sodium in the geothermal water, which is very similar to the hydrochemical text of the confined groundwater. And in this study, as we showed before, arsenic concentrate in the confined groundwater is higher than the phreatic groundwater. So we can derive that arsenic concentrate increased from shallow water and to geothermal water as a whole. And arsenic enrichment is mainly determined by the amount and max of the geothermal water with shallow groundwater. For fluoride, we can see that the fluoride content in the confined aquifers around the fault is ranged from 1.07 to 2.88 milligram per liter. But fluoride confined in the geothermal were much higher. This also indicates the possible of the mixing from the geothermal and the shallow groundwater. However, the fluoride outliners in the phreatic aquifers were distributed along the river and show very poor correlation with calcium. This suggests that the human activity or the evaporation may have a great influence on the concentration of fluoride in the unconfined groundwater. Finally, this is our conclusion. The first is we use the three methods in combined with the drinking water standard to derive the useful geochemical TVs, which are very helpful to identify the local of stem with unusual high concentrations. The second is for the confined aquifers. The geochemical TVs and concentrate of arsenic and fluoride are higher than this in the phreatic aquifers, while the concentrate of the nitrate was very low. This indicates that the geology or hydrogeology has a great influence on arsenic and fluoride concentrate in the groundwater, but human activity maybe have a great influence on the nitrate. The third is the spatial distribution of the outliners reveal that arsenic outliners were mainly distributed around the faults and the ground failures in both aquifers, while the fluoride outliners in the confined, as well as the forward outlines in the confined aquifers. This suggests that the nature source, such as the up movement and the method of the geothermal groundwater with the shallow groundwater result is the high concentration of arsenic and fluoride. That's my presentation. Thank you very much.
Thanks, Prof. Good presentation on the arsenic and fluoride and the sources and the alluding to impact of this. And findings and conclusion period. Please let's have comments on the presentation. You will assist me to translate. Yes.
I noticed in the upper final aquifer is sodium bicarbonate, and in the vertical aquifer is calcium. So my first understanding and question that I want to get clear is there any about evolution happening, between those two over time? Because do you have any interface where they are coming together? Then two, how long has those connate water been there? Within the unconfined beds, because he was saying now that the deeper you go, the more it becomes more saline. Yeah. So what's the age? Do you have any isotopic study or something that shows? So how long is it there, and what is the impact over time? Because we talk about aquifer, and particularly saline water, the lower the concentration, the lower the volume, the more the concentration of the salinity. So I saline water, they actually attach themselves to the matrix of the aquifer. Not all of them even go to the pumping. So they tend to increase in salinity. So do you experience this salinity as you pump more in the aquifer? And is there any evolution? Is water moving from sodium chloride, sodium bicarbonate to calcium bicarbonate over time, even for your vertical aquifer? So I just need clarification on that.
Oh, you want to take that? I think from what we read from the presentation, carbon 14 dating was not done. Okay. So they may not allude to the age of that. But because this is a natural system, so evolution is also seem to be taking place naturally as we go. Probably later on they may want that, but they seem just to focus on the sources, identifying this natural source and this. Prof, you want to comment?
Yeah, actually, this first study area, there are a lot of geothermal water. So the fluoridation of the storm water, we have make some impacts on the fresh water aquifers. So I guess the mineral, the salinity of the geothermal water is very high. So the pumping of the geothermal water will have already affected the fresh water.
So the evolution already taking place.
Yeah.
Wow.
I think we come from a lot of hot springs, and the ratio in Limpopo, we have a lot of hot springs taking place, very close to what she's presenting, and in similar setting. And having high fluoride is quite common with that process.
So can you in future do more of even modeling? They even predicts.
Your info modeling as well.
Where we are going.
Your special is the fastest change from carbonate in the mountains is the chloride. So that fastest change nothing is.
So shallow groundwater, so shallow aquifer, this area, it follows the mechanism. Around the mountain, fresh water, carbonate. And approaching the river, it becomes sodium chloride.
I think for the sake of the colleagues, one of the slides I like, which seem here, if you ask, then you become more or less like a rebel. Back, I think there's the method one. Yeah, quite a very good one. I think the method somewhere. So the method. This is just to see. Look at that one. Where we seem not doing much here. Most of our master student PhD students, if they present a method and you ask them the assumption behind their method, they are lost. They are lost. I'm doing SPSS, doing this and this. Okay, what is the underlying assumption? You are in methodology here. So any method, it has an underlying assumption to any technique that you're using. What is the mathematical equation? What is the thinking behind your method that you're using? You are lost.
It's difficult in the hydrochemistry.
Then they think you're fighting with them now. It's like you have done this initial view, yes. Whatever you are using, there should be underlying assumption to whatever method you want to tell people. Tell us this one so that we can see what you're finding. Then you are like, oh no, man. Thank you so much, Prof.
Thank you.
Yes, next. Next is Dr. I don't know whether I need to click here or say 3. So this is your mistake. 3 is easier, and then I have pay. I have to see the no big issues.
Then go to do with the jobs. Then we go to share. Share. And this one.
Yes. It's this one, okay.
This one?
Yeah.
This one.
Yeah.
Then share. Then you go here.
Hello, professors and students. My name is Li Lingxi. My presentation titles is groundwater nitrate pollution sources, apportionment under varying land use land cover patterns based on Google Earth image. The research content include 4 parts. The part 1 is introduction. This rapid urban development, fast population growth, and increased further application. The groundwater population problems are increasingly serious in the world, especially nitrate contamination. It causes eutrophication and harm human health. So many scholars study on nitrate groundwater. They use many methods, such as hydrochemistry, isotope, and experiment. However, land use change represent a link between national factors and humans in the ecological environment. It not only affects soil and rivers, but also leads to the deterioration of groundwater environment. In the past 3 decades, the land use pattern in the northern department of Qinling Mountains has undergone tremendous changes, leading to a conversion of numerous farmlands into kiwi fruit orchards. This paper contains 3 parts. we select study areas at the northern pyramid of Qinling Mountains in Shanxi Province, China. Its main region includes Mei-Kangchen, Zhouzhi-Kangchen, and Huyi district. We collect samples in 2015. Is groundwater inorganic indicator data set of Guangzhou Basin. And in the 2021, we collect 64 groundwater samples and 35 stable isotopes. We use a Google Earth image. It's powerful cloud computing and storage capabilities and high efficiency of data processing. This page is parameter setting, such as tidal phase, cloudiness, and test samples, and so on. Another method is Bayesian stable established mixing model. It quantifies the proportion of nitrate sources in the groundwater. In the table 1, we get the nitrate isotopes mean value and standard deviation. They come from a lot of references. So we get the result. We get the characterization of water chemistry. In the table 2, we can see the nitrate concentrate is increasing from 2015 to 2021 year. It has 27 samples exceeding national standards in China. And according to paper diagram, the groundwater temps are mainly big moment calcium maximum temp both 2015 and 2021. Then, according to the Google Earth image, we get the land use change. In the two papers, we can get the main tabs is farmland, and the total area of farmland and forest grassland increased. However, water and rural land decreased. According to our collection samples, we get the groundwater nitrate distribution. In the figures 5A, in 2015 years, gradually increased from the western of Zhouzhi to Mei-Kangchen is high concentrate. And in the 2021 year, the high nitrate concentrate is in Qituan, Hengqutuan, and Laodiantuan. The mean of nitrate concentrate in 2021 increased by 31.66 compared to 2015. It means the area of exceeding the standard show an expanding trend. Based on both the land use change and nitrate, we get the nitrate static value under different land use types. In the farmland and lowland, the nitrate concentrate is very high. Because a larger number of cultivated land was counted into kiwi fruit orchards, and application of nitrogen fertilizer increased significantly. On the other hand, the lack of unified treatment of domestic savage by nearby resentful. The larger permeable area in rural area where savage is easy to permeate. So we get the groundwater nitrate source. According to the chemistry and Estop method. In the figures 6a, nitrate comes from the mixture of soil, savage, and agricultural sources. And in the figures 6b, sources of natural include ammonia in presentation and fertilizer, soil nitrogen, and manual savage. In order to certain the densification of groundwater, so we get the figure 7. In figure 7, they are weakly negatively correlation. It shows that the densification of groundwater is weak and can be ignored. So the last, according to the mixer method, we get the proportional contributions of source under land use types. The research results show that soil nitrogen is the main source of nitrate in the groundwater, followed by manual savage and chemical fertilizer. It means excessively application of nitrogen fertilizer can lead to high soil nitrogen concentration, which can lead into groundwater. That's all. We get the 3 conclusions from 2015 to 2021 year. Farmland consistently remained as the primary land use type in the study area, and its area increasing. However, both the water and the lowland decreased, and the distribution of high concentrations nitrates gradually changes from the western area and to the whole area, and the average value increased. Especially natural concentrate increased significance in farmland and lowland. And the last, the mixture model result indicate that soil nitrogen was the primary source of natural to groundwater in the study area, followed by manual savage and chemistry fertilizer. While the contribution of nitrogen and chemistry fertilizer was higher in the farmland than rural land and forest grassland. Finally, thanks to the funding projects for this research. Thanks for listening.
Yeah, this is our last presentation before we go for lunch. The other presentation will be carried over to lunch, after lunch, after the afternoon session. Let's have comments, observation, colleagues, debate. Yes, sir.
I mean, it's not a comment or question. I just want to see that you mentioned you use the Google Earth Engine, and also the Landsat. But I didn't see where did we use it and how did we use it. Can you give me an idea? Do you want to use it, the Earth Engine and Landsat, to identify the land area or coverage, or what did you use?
就是你用Google Earth 了，用这个蓝赛，但是你讲说没有看到你这个到底是在哪用的，用在干啥？你就用这个东西是干啥用？
就是用它识别土地利用，就遥感解译。
Google Earth Landsat to recognize to identify the land use changes.
As a collection data tool. And for me, it's this one, maybe colleagues or of you, just conclusion. Yeah, last bullet. Last bullet. I'm trying to see how chemical fertilizers were separated from soil nitrogen. I would think the fertilizers are put in soil. So if the fertilizers are being put into soil, and then while in the soil, how do you separate the united? Yeah, something around that one.
But it's not the same question I have. It's not clear to me between because it said, I want to learn is the soil nitrogen, it's categorized differently from the fertilizer, So because I think the study is saying that the soil nitrogen is the major source of nitrates in the water, followed by the fertilizers. So how does it mean the soil releases its own nitrogen separately from the fertilizers? I can't.
We just want to see how it was experimental design.
Gas means the fertilizer. The source from fertilizer is direct soil. When the farmers use fertilizer may go into the aquifer with the irrigation water. The direct input the aquifer. I think if we use this. And the soil nitrogen, actually, I guess the soil nitrogen comes from fertilizer, because this area has a history of agriculture for over 2,000 years. So a lot of fertilizer has already appeared in the soil. So this
from the soil.
Sorry,
Like tangential clearly now. So it means there is two sources now. One is directly from application and infiltration calculation, just straight to the water, direction or whatever. And there's another one that is historic, that has been there as part of the soil already. So it is the one that is now dominating and contributing more to pollution.
Actually, the study area, how this kind of process soil nitrogen is separated. The study area, I think it's a lowest plateau. Lowest plateau is like a Maput land. That's what it's completely alluvium formations. The thickness of that, I think, how many 6 kilometers or something. How many kilometer thickness of that? Yes, thickness of the soil. I think more than a kilometer. You know,
The thickness maybe 300.
300
meters.
You imagine this lowest plateau. What is the concept of that? It's mountainous area. All the erosion taking place from the mountain deposited the sedimentation. That's what the thickness of the 300-meter deposition is not used. So when the soil it is the alluvium, completely unconsolidated formation. It's a 2000 years agricultural activities. Maybe agrochemical activities maybe last 100 years. Before we can't expect the nitrogen, even though that's a biofertilizer when they use. The nitrogen is infiltrating in vertically, which is moving into the aquifers. Okay. So when you are doing the already nitrate, it is reaching towards the sedimentary terrace. It is not completely reaching to the aquifers. It is already settled in the layer. When you are giving the new forming, they are adding more nitrate. You know the nitrogen, phosphate, ammonia they are adding. So that is already existing nitrogen is there in the soil. The new fertilizers, agrochemicals is adding. That is a two difference. That's what the soil nitrogen. I'm right.
And that's one reason. And I think this area is agricultural area. I think some plant roots, they have some nitrate, dissolve some nitrate. When they die, the nitrate will come back to the soil. So both accumulated from fertilizer and from the plant, they call this the soil.
And how deep are the boreholes? How deep is the borehole?
Borehole deep. How much is the depth of the borehole?
To get to that area.
That's in this area, the widow zone is not as high as mentioned 300. The widow zone is 40 like the whole 20 meters. So in this shallow this area.
There is more direct fertilizer, recent fertilizer So then, sorry, sir. Then I see in the Piper diagram, I can see also the trend of evolution. You know, it's good to the Piper diagram. So that you can see in the right, you can see the evolution, you know, trying to move gradually from the second one particularly there. Yeah. Does it now have, because I see the 5-year study from 2015 to 2021, and the study, the red ones are in 2021. I can see that a bit, you know, it means the concentration is reducing or decreasing. So what is the mechanism behind? Is it dilution? Is it recent farming? What's the mechanism behind the evolution? You know, trying to move from 60, 50, 40 to almost 100.
Actually, this diagram contains samples from the mountainous area and towards the approaching the river. Big area from mountains. So in mountains we have more calcium and carbon. But proposing the river for you reduce the
Also, in this type of when the bicarbonate calcium addition, it will also we can create the trend lines. Fresh water, it's directly recharged. When it is directly recharged into the aquifers, the bicarbonate and calcium. When it is travel along the boundaries, the distance, then the characteristics will be changed. But that one is mentioned that it's mountainous area, more rainfall. Then it's I think the trend line we created is a fresh water.
My suggestion also that the market on the spatial, taking those samples from specific borrowers and then revert this soil land use market. So we can identify which crop is more contributing for that quality. Let's verify these changes.
So I think it's concluded that your soil has vast reserves of nitrates and other additives that are compound fertilizers in your resource. The question is, how do you fix the problem? Rather than contributing to the problem by adding more fertilizers. In the sugar experiment station where I worked some time ago, we adopted the approach of estimating how much there is in the soil by doing soil surveys and analyzing for these things. And then also doing that through the leaves, extracting the composition, degrading the composition and teasing out exactly what the composition is in terms of the enrichment of the different elements. And from there, prescribing to the farmers what type of fertilizer should be used so that you would minimize some and you will load on others. We find where the deficiencies are, you load on those. So obviously you need to have cooperation from the farmers, you need to have a system in place, etc. But that tended to give a better yield as well, because you're now analyzing the plant and seeing what the plant needs, and you're helping the plant to grow better and be better. So I think take it from there now and look for solutions, now that the problem is identified.
Yeah, I have been kind of in many areas that it's not farmers use fertilizer as they wish. We cannot do this. But I guess your perspective is very clear. We should do this. We should use the fertilizer according to the needs of the plant.
So we always need the core water studies. We in the farming area, we did a lot of piezometers in the different levels. When the infiltration taking place, it will show how much of nitrate in the each depth, maybe at 50 centimeters, and each and every centimeters. All the same thing they will do it in the field laboratory also. They collect the core samples. These all the how to control the fertilizers. The piezometers are to be can fill. Then the add the fertilizer in the top. When the add the fertilizers, it's moving along the boundary. Then we can measure the how much infiltration is taking place. That one also. The physical studies can tell how much we needed for the fertilizer in that study. Yeah.
Good debates for applicants. This is the last one. Oh, last one.
Okay. I just for a general question, because when we talk about fertilizer, we all come from one area or the other where they apply fertilizer in the farm. And in the shown crop yield is better. Now, does it imply that the organic fertilizers are the major problem? In case maybe if we go out, for instance, to talk to farmers about the effect of fertilizers on the environment, do we encourage them to use organic fertilizer or inorganic fertilizer? Which one pollutes the underground water much more? Maybe like using cow dung, refuse from the poultry farms and all the rest of them. Do they give the same pollutant effect as the inorganic fertilizer?
big differences there. You can't compare with the organic and inorganic fertilizers. Organic fertilizers is comparatively very less. Like yeah, less chemicals. Also, you mentioned the cow dung, and that before that, 100 years before, there is no inorganic chemical fertilizer. All is a natural fertilizers. Like the cow dung, they're using all the waste, the plants. Also, some certain type of crop is there. Just actually, the certain some area, the farming is 2 times only. 3 months, remaining 4 months, they have the natural crops is there. Just plant the seed, leave it. When they want to do the again reforming, that machine will come and mix all the I don't know what crop that is, like the fertilizer crop is. It will come grow up to 1 meter. Then that crop is mixed with the soil. Then they will leave it 2-3 months. When it is completely fertile the land, again they will reform. Forming is their continuous. But that is a natural fertilizer. Nitrogen is increasing in the soil. It's a big difference, organic and inorganic. But it's difficult. Because, for example, here, in sugarcane farm, there is nothing is less than 200 hectares. If you have a small land, we can think about that. Here, the 1,000-hectare land, each and every farms, 1,000, 2,000 hectares of sugarcanes. In Liverpool, if you go there, 200, 300 hectares, vegetables. Cultivating banana and the these all there. It's difficult for getting. There is no source.
Very good. Fertilizers and farmers, they will use the one that is for use. We as environmentalists, we try to lower down. It's a big process. They all want to harvest more and sell more than that. But thank you very much for the observations. We need to protect environment as environmentalists, water scientists. And thank you for the contribution of knowledge to the science. And we need that knowledge so that we can improve the practice in future. Let's give and that hand is also for the session, so I hand over to the director of food.
What time we can meet the professor again? Maybe
it's a talk.
Our first one is right, I think. Please.
Yeah.
Okay. Yes, we can meet again. Our first one. So another 3 more presentations. We will try to finish maybe before. Yeah. Before 3 January.
Let's go each before we finish.
Maybe the people are here, they want to start gazing in the evening, and go to start gazing.
I think it's a time.
Yeah, so it's planning to do the on top of the library.
Okay.
So there will be 2 kind of go, one from physics, one from myself.
Okay.
So if they want to watch any stuff, you are more than welcome to come.
Or maybe after finish this one, we can go.
Yeah.
Hey,
No.
Only night.
So it can take the night to be in the evening hours, and we will see if
Why you can't take it home and see?
So the place has to be above the ground, and then you need to be have darkness in the back. So that's why we are using at the top of the library. That is there.
How big is the instrument? It's big.
It's big. It's not a big, but it does not take account that the background light. So the background light has to be.
You can go take it home this afternoon, maybe after you
may have the light outside, right? Because you may have the street lights and the
nothing. You are living in bush.
Nothing. We will see what we can do.
Okay.
Just told the Sibo from
Yeah.
physics.
Okay.
He said he put it on the marketing department as well.
Oh,
And if there are more.
okay, that means we will not disturb. Yeah.
But I think before we go for dinner, we can have one travel, come here and then they can.
Yeah.
Guys gonna see you like you. The packaging is appealing, how you look is appealing. I approach you, then we go on the talking stage. So within the talking stage, I am trying to assess if we're compatible. Do I also like you beyond how you look? You understand? So sometimes I really am physically attracted to you, but you're a starfish.
Yeah.
So I keep on going on those talking stages, hoping that I'll unpack something.
Yeah.
You understand? Something is gonna come out.
You have to know if the stove is on 6.
Yes.
But then don't you think you need to take also accountability for like wishful thinking? Because you met the girl on the date, she wasn't putting in any efforts. The fact that you went back, that's on you.
But
yeah, I have a problem with that too. Because
No, but you guys-
niggas always want to tell you problems after he's fucked you. You know what I'm saying? With you, okay, fine.
That's true.
Like for instance, you probably knew you met me, you liked the way I look and all of that, and then maybe I did something to turn you off. But you're still gonna fuck me, and then you're gonna tell me after you fucked me that you know what, you're kind of not really my type, or ghost me. So what's up with that? I don't know if I'm off topic, but
I think
please help me.
Sino is the best guy to answer that one.
Please.
Yeah,
Oh.
Sino, why do you smash these girls and ghost them?
Knowing very well. No, knowing very well.
I am virgin, purely virgin.
You see, he can't even pronounce the word. You heard that?
He really doesn't know it.
He's a pure virgin. Chief, tell us, Chief, why do you ghost these women only after smashing?
I'm gonna speak for I think most
And
of the
you
guys.
knew that I was not your type, but you still fucked me. Why?
No, you are my type. But the stove wasn't on 6.
No, the stove wasn't on 6 before you fucked me. Why did you fuck me?
You must understand what the stove is, Chief.
Okay, what is it?
Do you get the stove for him? Do you know what the stove is?
What's the stove?
Please enlighten. I think you know stove.
you know what
I don't know what the stove is.
Stove is.
I don't know what the stove is.
I thought it's stove Masuku 6 is when everything is sharp.
No.
Like,
I don't know
everything
what
is
the
hot.
stove is.
No,
What
the
is
stove when it's on 6.
The plate.
The
It's
plate
hot.
is hot.
Which
Like, yeah, she's.
which plate?
So,
Tell
are you
them,
gonna
Chief,
tell
them,
us?
Chief, tell them.
Is
What's
it-
the
is
story.
Break it
What we're
down.
thinking.
Break it down.
Yeah.
Break it down.
But this one knows what the
just
stove
knows.
is. Yeah.
I don't.
Level, you know.
Okay, just be frank, just be lampert about it. Let's hear.
stove.
What is the
This
The
is the
oyster.
clear communication.
The
we were
oyster.
talking
Oh,
about
the
earlier.
oyster. Nah,
The oyster is
nah,
the-
nah. Me, I mean, Uguti, you meet me. I'm a nice girl and all of that. Maybe the second time you see me, you know, we go
No,
on
but
a
the
date.
reason probably maybe the guy ghosted you after you did the things.
Yeah.
Is because the stove wasn't on 6. It wasn't pleasurable.
Let
it
me help
wasn't
you,
nice.
Fahima. Let me help you, Fahima. The stove is the thing that connects. Do you
Yes.
understand? Do you get what the stove is
Yeah.
now?
No, I get it.
So
Yes.
he's saying, you're nice,
So over to you.
Hello everyone, my name is Xu Fei. I come from China University. Okay. This is my report outline. First, it's essential to provide some background. Globally, groundwater is an important source for industrial, agriculture, and drinking purposes, especially in arid and semi-arid areas. Groundwater resources are more important due to limited rainfall and surface water. Groundwater is closely linked to the surface land use, and rapid changes in land use patterns in recent years have altered the original land use patterns, thus changing the groundwater circulation system and affecting groundwater quality. In the past few decades, numerous studies have been conducted to examine the relationship between land use, land cover, and groundwater pollution. In recent years, the key to determine the relationship between land use patterns and the groundwater environment has been to quantify land use patterns using contribution domains. Contribution domain refers to an area in the vicinity of a well. Land use patterns in the contributing domain significantly affect the groundwater quality in the well. And the land use patterns outside the contributing domain will have little effect on groundwater quality. In early studies, the contributing domain was often set up as a circular area centered on a well to analyze the impact of land use on groundwater quality with a radius range of 100 to 3,200 meters, depending on the actual conditions of the study area. Then two scholars proposed a searchlight-shaped contributing domain that takes into account the direction of groundwater flow. However, this contributing domain considers only straight groundwater streamline and He and Wu. The members of our research team proposed a cold streamline searchlight model that considers the actual direction of groundwater flow. This improved model is more realistic and reasonable for studying the effects of land use on groundwater quality. On the study area, Guangdong Basin belongs to the semi-humid and semi-arid region of northwest China, where groundwater is the most important water resources. Most studies have focused on groundwater level changes and water quality evolution, and there is a lack of comprehensive studies in exploring the relationship between land use patterns and groundwater. Also, the main objectives of this study is to determine the hydrochemical characteristics of groundwater and their spatial distribution in the Guangdong Basin, and to determine the relationship between land use patterns and hydrochemical parameters of groundwater, and to forecast the land use patterns for 2030 and their potential impacts on groundwater quality in the Guangdong Basin. To achieve above objectives, we need the groundwater level data, the groundwater quality data, and the land use data. In the study, the land use data in 2020 from the China land cover dataset, and the groundwater quality data also from an open dataset. For the groundwater quality data, 6 hydrochemical parameters were selected and other hydrochemical parameters were neglected because they were either below the detection limit or not considered pollution indicators. We also need the land use data with the resolution of 30 meters. There are 7 types, including forest, shrubland, grassland, cropland, urban land, bare land, and water body. And we also need some data to building a land use for the land use simulation. A total of 15 drivers, including social, economical, natural environment, roads, water systems, high-speed rail stations, and other factors that may drive land use change were considered. This is my research framework. Firstly, we need to analyze the groundwater quality characteristics and the different land use types. Then we use the GIS extract to extract the area of each land use type in the CSSL model. After obtaining the quantified results, we use the Spearman correlation analysis to evaluate the relationship between the percentage of land use types and the groundwater quality. In addition, stepwise the regression analysis was used to eliminate land use types that didn't have a significant effect on water quality. Then we building a model to predict the land use patterns in 2030. To building this model, in this study, the land use of the study area in 2030 was determined based on the land use data for 2 years, using 15 driving factors and selecting land use transfer routes and domain widths. To verify the accuracy of prediction results, we predicted the land use patterns in 2020 based on the land use data in 2022, and compared the prediction results with the real land use data in the same year. At last, assessment of possible future changes in groundwater quality as a result of land use changes based on revealing the relationship between current land use patterns and groundwater quality. Now I'd like to move on to the third part, the results and the discussion. The first objective is to determine the groundwater quality characteristics. We can say that high values of sodium sulfate, chloride, fluoride, and chromium are mainly found in Weinan City. In this figure, we can see that. Probably due to intensive human activities, and the high value of fluoride is due to the widespread distribution of quaternary noise and clay with high fluoride content, which lead to higher fluoride concentration in groundwater through water rock interactions. At the same time, fluoride in groundwater is enriched in the water zone with evaporation and returns to groundwater through rainfall or irrigation, forming high fluoride concentration. The high concentration of chromium may be due to the geological characteristics of the loess in the region that promote the leaching to groundwater on the one hand and the influence of human activities on the other hand. The high concentration of nitrate dispersed in the study area is attributed to the widely distributed agricultural land. The overall better water quality in the southern-west part of the study area may be due to the lower population and reduced agricultural activities. This figure shows the land use patterns of the Guangdong Basin for 2020. We can see study area is a traditional agricultural area with the largest proportion of cropland followed by urban land. Most forests concentrated along the southern border of the study area. The water bodies are distributed throughout the study area. In addition, shrubland are rarely found in the study area, occupying the lowest surface part of the study area. To analyze the relationship between groundwater quality and land use types in the Guangdong Basin, the percentage of groundwater parameters exceeding the groundwater quality standard in each land use type were determined. The results revealed very few sampling points located in the forest, grassland, and water body types. Hence, groundwater quality indicators may not reflect their general characteristics in these areas. Therefore, the groundwater quality characteristics in cropland, urban land, and bioland were evaluated in this study. We can see that high values of nitrate are mainly found in cropland. It's probably due to the high application of fertilizers. Higher exceedance rates of fluoride and chromium in urban land may be due to the wide distribution of industrial source in the city, whereas high concentrations of sodium chloride and sulfate found in bioland and urban land. Then we use the Spearman correlation analysis. Before analyzing the relationship between groundwater quality and land use types, the percentage of each land use type in the CSSL model was calculated for each sampling point. The composition of land use types in this model for each word sample set is shown in this figure. This is the Spearman correlation and set results. We can say that most of groundwater parameters were negatively correlated with forest, shrubland, and water bodies, while some groundwater parameters were positively correlated with cropland and bioland. To further analyze the relationship between water quality parameters and land use types, stepwise multi-regression analysis was performed for each groundwater indicator and land use type. We can see groundwater parameters are mainly influenced by four land use types, namely forest, cropland, bioland, and water bodies. Bioland significantly affected sodium chloride and sulfate. The forest area showed significant negative correlations with sodium and fluoride. And all stepwise regression results were consistent with those obtained using the Spearman correlation analysis. After obtained their relationship, then we predicted the land use patterns in 2030 with using a class model. This table lists the land use conversion from 2020 to 2030 and labels the conversions for land use type over an area of 50 square kilometer. From 2020 to 2030, there is a significant increase in urban land. In 2030, cropland is significantly reduced and converted to urban land, grassland, water bodies, and forest. Some grassland and forests converted to cropland. In addition, small balelands are mainly converted into cropland and urban land. The next part is prediction of groundwater quality based on land use change. The above analysis shows that the greater the proportion of forest, the better the groundwater quality. Therefore, the groundwater quality here may deteriorate in the future due to the reduction of forest areas. And the predicted reduction of bioland is mainly concentrated in the middle and upper Guangdong Basin, with some conversion of bioland to forest, which may improve groundwater quality in the region. And understanding the relationship between land use and groundwater quality and analyzing possible changes in groundwater quality by predicting changes in land use can help managers take measures to protect water resources in advance. This is the main conclusions. Most of the parameters show higher concentrations in the noise of Weihe River than the source, and Spearman correlation and stepwise multiple regression analysis revealed the forest and water bodies had significant negative correlations with the sodium chloride sulfate and chromium, and lead to a reduction in their concentration, while bioland and cropland had positive correlations with these parameters. There is a conversion of some forest areas in the southern part of the study area to cropland, which may result in groundwater quality deterioration in this area, while the observed reduction of bioland in the study area may partially improve the groundwater quality. That's all. Thanks for your listening.
Thank you so much. Very interesting talk. Ladies and gentlemen, let's give another round of applause for the excellent delivery and for speaking English so well, coming from China. I open the floor now to some questions and comments. No critiques, please, just comments and questions. We'll criticize later. Let's go for it, guys. Come, Prof. I can see you're about to ask a question.
A study I did on using land use now for my LUSC. It's for surface water. So, but it's very difficult to see it with the groundwater, but you've been able to do it very, very well. I can really attest to that. But what do you think is more responsible for the water quality in terms of you see some high, you know? So are you just using the land use in terms of, if you say, okay, agricultural activities or something? Do you, as we were saying the other time about the ground truth, you know, sometimes because it could be beyond farming, you know, it's farmland. It could be some point source pollution, you know, that is actually dispersing towards all the groundwater, you know. So we need to also be a bit more careful, you know, because the land use that cover the Sentinel, all these Landsats cannot really pinpoint that, oh, the pollution in this farmland, it's not necessarily from the farmland. It could actually be from the wastewater treatment plant. Do you understand? And it from there pollutes all the groundwater, as big as it is, you know. So, but it's a very nice study, you know. So, yes.
Thank you. Yes.
Really, I very much appreciate this presentation. And in addition to that, in this study, in correlation, what is the level of degree of correlation? Yeah. Also, really, groundwater quality index map is, you know, because we are not only focusing on specific water quality parameters, only nitrogen. So how is this partially buffering that specific source area, for example, for one water border? So water quality index map and how that index changes in that area. So that's
Okay, study is quite similar to my first talk. Just investigating the correlation between land use and overall water quality. And I think more in-depth study should be conducted to find the true relationship. You know, now the present relationship is just a statistical relationship. It's sometimes the statistics can yield some wrong results. So I guess we should set up models and maybe other techniques to find the true relationship. From students,
Any other comments? I think the way in which the entire study is conceptualized is very, very concise, tight, and very well done. Even the outcomes, you know, it's so clear what the outcomes are. So I think it's a brilliant presentation, brilliant study, and something to take note of, particularly for students who know how to actually tackle problems. So I think very well done. Excellent. Thank you so much, guys. Any other comments? Any other comments?
You ask you can have, you know, in South Africa, in particularly in second province, in this side, we have a lot of commercial forests. Like here, the Mandi, Sapi, is all the factory industries. They own a lot of farms. It's like a real forest. Big land mass they're capturing in the air provinces. Once in 5 years, depends on the type of the tree. Like normally eucalyptus is once in 5 years, so pine tree maybe 6-7 years. So there is no any study here. How the groundwater, you know, the groundwater, not quality, groundwater percentage. When there are a lot of forest, you need more water, you are absorbing a lot of water. How you can quantify how the water availability is different during the not harvesting, because once in 5 years. The differences maybe when the harvesting the forest, maybe water level, I suspect water level maybe is more. When the trees is growing, the water level variation, is there any, how we can quantify like that? Is there any possible techniques to quantify?
From my experience, I know some people are researching in this direction. They are trying to quantify the quantity of a certain plant or certain tree needs. But I think at present it's not easy. It's not easy to quantify. Some people use isotopes, different isotopes to quantify the processes of trees or plants to use water. But I guess the accuracy needs to be improved.
Here, even in the particular coastal area, a lot of commercial farming, we not traveling so long. It's a lot of groundwater recharge is affecting due to these plantations. So that was also maybe in the land use, land cover change.
I will share a study with you. We did in IGS. It was the WRC funded project. Then in 2016. So they went to these commercial farms and they dug close to 50 boreholes, to actually monitor how the land use there is affecting the groundwater. So they worked on that project. They use geophysics, they use isotopes, they also use flow, the normal flow contesting and others. Because you could see at the bank of the river where the groundwater is discharging into the river system, so you could determine the flow direction, So they now use isotopes of the tree, and isotopes in the water. So they extract. So we collaborated with these agrologists and agronomy, from agriculture, whereby from the tree plants, they were extracting some moisture. Then we were getting the isotopes from the moisture and the isotope from the groundwater and doing some correlation to see where is it taken. Because a personal study I also did there, because we noticed that we have a lot of invasive trees, acacias and others, and they use a lot of our groundwater actually, because the groundwater sometimes not very deep. So they use, and it's along, you see a particular area, the trees are so green, in a desert or in a semi-arid area, in a very green tree. So they're using a lot of groundwater. So people are not doing much of these studies, to see how much of these trees are using in our groundwater. So the land use land cover itself, and people are planting more. So the more trees they plant, where are these trees surviving? So they're actually using the groundwater that are there. So I think it's really
this plantation, the groundwater abstraction is more than what human we are using. The whole area is private, the commercial for it. So that will also, I hope it will be a fit for the.
In addition, Prof, in fact, in Free State, they use more of, there is a lot of farmlands. Agricultural activity so high. In fact, in the country, farmers use more water than any other person. They use 60%. Now, in Free State, it is borehole they use majorly. So they attract a lot of water for irrigation. And this water doesn't go back because we have a negative recharge, net water cycle. So it doesn't go back there. And that is where I can see the impact of the study as well, that we can apply even there to see the land use on farmland itself and see the water level, groundwater level, and how it goes, and how. One last comment.
For the question, the last, I mentioned this moment from what power data. There is a biomass water productivity, and there's a water monitoring system that online. Also, I think for UWC, we brought America, she used remote sensing techniques to estimate how much water is taken from the first.
Thank you so much, guys. Probably we can discuss later. Thank you so much, man. Okay, we're moving on to our next presentation, and this is by Mrs. Patience Akinpelo. It's all here.
Let's get.
All right.
Okay.
Okay, so the talk is going to be on geochemical evaluation of groundwater and health risk assessment of Luhuvu, what is that pronunciation? Catchment area in South Africa. Okay. We have it a minute ago. Right, here's this one. Yeah. Okay, you can bring it to show. Up there, right show. You can keep it like that. It's fine. Is it okay?
Good. Let me get a full slideshow. Okay, observations?
Yeah. My name is Oluwadimima Patience. I'm presenting on the chemical evaluation of groundwater and earth risk assessment of Lubu catchment area, South Africa. So I'm supervised by Professor Petrie. So as we all know that our groundwater is being supported by 2/3 of groundwater is supporting 2/3 of the world population, and by supplying fresh water for various purposes. The same thing when we come down to South Africa, where surface water are limited, they are not evenly distributed. Groundwater has been an important source of fresh water. And the same thing, this South Africa has been declared from what we have been coming around is a water scarce country or water stressed country. And why? Because of the extreme climate condition that has been taking place in our country here. And some other factors such as natural factors, human activities, overexploitation as bring a kind of issue on the availability and quality of our water. And in South Africa here, about 70% of our population depends on groundwater for drinking and other purposes. Coming down to the Lubu catchment, we rely much on groundwater because it is more reachable to us, is cost efficient, and is, I think, portable. Also, poor management of our untreated domestic waste, agricultural runoff, and some other factors that affect our groundwater system. And with this, we have to have a knowledge of our groundwater by checking our hydrochemical characteristics and some other qualities. And from this, World Health Organization has given us some limits, or even that's a broad World Health talking about the whole world. Coming down to our place in South Africa, we have the DWAF, Department of Water and Affairs and Forestry. So we have some limits for all these eons. And when these limits are being exceeded, our water become problematic when we consume them. With this, it is important for us to evaluate our quality of water resources due to their direct impact on our health and crop yield. From the study area, we have some researchers that have gone through. Our prof has been able to do some research in that place and was able to come out with a confirmation that the water chemistry in the well analyzed are affected by research process and surface contamination. Also, Emmanuel Netonoda, 2018, also reported some geochemical mechanism that has taken place as mineral weathering, reverse ion exchange, irrigation return flow, and also from the water quality index, 50% of the water are poor to unsuitable for drinking. From this study, I'll focus on the hydrogeochemical characteristics, the water quality, and our health risk assessment. So for the study area, the catchment is located in Limpopo province of South Africa with an undulating topography, low mountains, hills with moderate relief, slope of about 150, more than 1 meter of local relief. Then the height is between 450 to 1,425 meters above mean sea level. The climate is a semi-arid, coupled with mean annual rainfall varying from 350 to 450 millimeter. 95% of the rain takes place between October and March. Then our temperature is between 25 to 40 degrees in the summer, and during the winter, 22 to 26. Also, there is a dam, major dam that is along the river in the catchment. Then the groundwater is used in rural activities like agriculture as a supplement to surface water. In the eastern part, the Sapabag rock composed of copper mineralization, volcanic rock at the northern part, sequence of sedimentary and basaltic lava in the eastern part. Then the area, the formation is composed of lava, sandstone, the limestone, the carbonate shale, and dolomite serve as the water source. That is the water. The catchment has fractured aquifers, semi-crystalline rock, and the catchment is for agriculture in its high production. And these are some of the fruits. Also, we have settlements. Looking at the map, I have the geology map and the land use map there. From the map, we have our gneisses, our sedimentary rock. Then we have the basalt, the arsenic, the marble. So, and this, you can see that our gneisses covers almost a sizable number of the catchment, as well as our alnites. So for the sedimentary rock, it's located at the extreme northern part and at the middle. And for the land use map, the area, 70% of the area used for cultivation, forest land and grassland. We have the mining and quarries, though not really visible from this map. When you zoom it, they are the northern parts of the area. Then we have some build-up area that is shown in the red color, build-up areas. Coming to the methods applied for the research. 84 samples of groundwater were collected for the research. And from the first map that I showed you, I was not able to explain. We have all the samples collected, scattered all around the the catchment where the samples really took place. Then, as we are all aware of the normal protocol that we normally do on the field while collecting our samples, so I will not go into that. We have our cations and anions being analyzed. We have our physiochemical parameters. We have the trace methods, and these are the methods used in analyzing them. Also, we have our GI software was used in generation of the location map, the geological map, and the land use. So the cluster done through and orange software. So I come to one of the methods, water quality index. This was fundamental by Houghton, was proposed by Houghton in 1965. And according to his method, it involves 5 steps. And from the steps, number one, the first step, which is assigning of weights, is the most important and the first to be carried out. A weight is assigned to each of the parameters that we are in need for the estimation of the water quality index. So, and the weights are between 1 to 5. And in order for us to fix these weights to our parameters, we consider the significance of each of these parameters to our water quality. And in all 18 parameters were used from ions and trace matter for the study. And this is the rating scale that I used after estimation of that is carrying out the analysis. We have 0 to 25, giving us an excellent water quality, 26 to 50, good quality water, 51 to 75, poor water quality, 76 to 100, very poor water quality, and greater than 100, giving an unsuitable quality. Then one of the methods also, the earth risk assessment, As we all know that our elements or our metals, they occur naturally, and but environmental contaminations and some other factors brings a kind of effect that is cause health problem. So the health risk assessment estimate the degree in the presence of toxic, that is the degree of these metals in our groundwater when we consume them. So potential health risk is a function of age, gender, body weight, time, frequency of water consumed, the exposure, and talking about the nutritional status of the individual that has maybe consumed or is at risk. And we have carcinogenic and non-carcinogenic as the categories of risk. Our exposure routes, they are in 3 forms, but I'm considering the injection and the derma. The derma is talking about when you bathe with the water, your skin. So I'm considering it for adults and children. I'm using this equation from United States Environmental Protection Agency, 2004. The table I have here, so these are the equations. The CDI is the chronic daily intake for injection for derma. My CW is the concentration of the metal. IR is the injection rate. EF is the exposure frequency. ED is the exposure duration. BW is the body weight. 80 is the average time. Then coming to the derma, there are some differences. The SA is the surface area of the skin. My KP is the permeability coefficient. So the non-carcinogenic of trace metals was evaluated using the RFD, which is the reference dose of elements, and the ABSGR, gastrointestinal absorption factor. So these mentioned values are obtained from these 2 references. Then after the calculation of the this coefficient, other coefficients, I move down to hazard index. So, and that is how to get our hazard index. If our hazard coefficient and our hazard index is below 1 after our estimation, no carcinogenic risk is not expected to occur. But when they are greater than 1, it's a suggest that gives us concern that there's no carcinogenic effects on our health. So from the result and discussion from our WQI, this table is showing the weight assigned to each of the parameters. The other weight is the relative weight. We calculate the relative weight from the summation of the assigned weight over each of the assigned weight for the parameters, and 2 limits were used for comparison, the 12 and the WHO, and these are the results I got there. When you look at the 2 results, there are no water samples that falls in the, that is in the excellent. None of them is showing an excellent scaling. So we have, for the WHO, we have 7% as good, 13% as poor, then 1.2 as very poor, and 8.3 as unfit. Coming down to our dwarf, we have 54% as good, 26 poor, 6% very poor, and 14% unfit for drinking. So we also have some hydrogeochemical characteristics that we did. Then the water types, the carbonate, calcium bicarbonate, sodium chloride, calcium chloride mixed type, 2 mixed types, so that was found using a Piper plot. And as we can see, is a kind of mixed reaction process that is taking place, a kind of mechanism. You can see the way it's moving from our calcium carbonate down to our sodium chloride. And we can see that calcium carbonate fasces shows that the water is a freshly recharging water. And it can also say that it indicates carbonate and silicate welding are taking place. The sodium chloride and the calcium magnesium sodium chloride can indicate the influence of a ionic exchange process or evaporation. Then I did some plots on the Gibbs diagram just to show the evolution. So we can see majority of the samples fall in the precipitation dominance and some mechanisms in our rock dominance and evaporation. But with this, I can say that the water that falls in the precipitation dominance is, there is this scenario, it's confirm our calcium bicarbonate as a fresh water. We can also say that the water is yet to have a sufficient contact time with our minerals for geochemical modification before getting evaporated. The other diagram below is the Van Wiederdom. It's also confirming the process is taking place, taking place from our Gibbs diagram. The HT there is atmospheric or our precipitation dominance. The L there is a lithosphere or the rock-water interaction. Then the TH is a so we can say salinity or evaporation. So as we can see, the water is moving up, then data is coming towards the evaporation. Though we have few samples plotted there, the same thing, you can see 2 samples here, 2 samples at the evaporation site. Then the third diagram also confirms that there is evaporation happening, but most of our samples falls towards the sodium chloride. And this can tell us that an anthropogenic activity is taking place. This is confirmed from the northern parts of the study area from our map, where we have the mining activities taking place, and it can also be due to ion exchange. So I have the silicate mechanism processes, that is one of the mechanisms that's controlling our groundwater system. So I have a plot of calcium and magnesium against our total cations. And from there, the 2 graphs, the equiline is there. Then most of the samples are falling below. They are enriched in the total cations. And this suggests that the ions in the groundwater are due to silicates welding process. The third diagram is a confirmation of this. The sodium chloride was plotted with the well numbers, that is the samples. And we can see 2 activities taking 2 different processes taking place. We have the anthropogenic, which carries about 53%, and our silicate carrying about 42%. Carbonate dissolution. This graph also is showing the disparity between carbonate dissolution and silicate welding. Coming to the other plots, we have 13% carbon and dolomite dissolution, 58% the calcite dissolution, while 9.5 telling us that about the silicate welding. So also a molar or ratio of calcium and magnesium was done. The average is 1.73. So 63% is greater than 1, telling us calcite dissolution, 23% greater than 2, our silicate welding, and between 1 and less than 1, our dolomite dissolution. So this is the ionic exchange. So the first graph there, it's not really giving us the kind of scenarios. So other ones were used to confirm. And the second one was able to confirm our reverse ion exchange, and coming down to our chloroalkaline indices gave us a good picture. Though some samples are falling below, at the negative part, showing the ion exchange, but majority are falling towards the reverse ion exchange. Then the cluster analysis that was carried out, because of time, we are not able to do some statistical analysis much. So we have 3 clusters there, but I'm focusing on 2, the C1 and the C3. The C1 indicates an influence from mining operation and agricultural activities in the northern parts, and also where we have a dominant of shale. The C3 is the weathering of silicates in the area of gneiss and basalt, and that place has a lower elevated area with high evaporation. So earth risk assessment, after the estimation using the trace method with the equation I showed you earlier, I was able to arrive at some graphs, and I have the hazard quotient graph, the hazard quotient for injection, for DEMA, for the hazard index. The light color is showing for children, while the blue color is showing for the adults. Any values greater than 1 shows there's possibility of a non-carcinogenic effect. So for children, we have the silver, we have the cobalt, we have the lead, giving us a greater than 1 value. So for the DEMA, there's none, both for children and for adults, that is having values greater than 1. And coming to our hazard index, we have values also that are greater than 1. And this tells us that drinking polluted water can have a long-term effect on women, especially for our children that are having some risk with what is being shown here. Study that has shown that about 20% of the worm cancer and 70% of the total disease around the world are due to injections of contaminated water. So continuous drinking of this water, especially for our children, as I've said, may damage their central nervous system, their brain, and their kidney. So in conclusion, the water is fit for drinking based on the standard limits of WHO and DWAF, except for few locations. Then using our WQI, 77% of the water are good for drinking. And those that are unfit are concentrated in the areas that is at the northern parts, coming to check our map with the results we have gotten, and some of the build-up areas where we have a domestic waste infiltrating into our water system. The calcium bicarbonate is a dominant water type, followed by sodium, calcium chloride, and some mixed type in the study area. The dominant mechanism is precipitation, with some mixed mechanism of rock interaction and evaporation. Silicate weathering, carbonate dissolution, and reverse ion is also confirmed, as well as anthropogenic activities. And the little statistics that was done also was able to confirm the hydrogeochemical processes. And for our health risk, there's no presence of a non-carcinogenic risk, except for our children in DAMA, that is hazard quotient of DAMA and hazard index in these 3 meters. So, though this work was done in a limited time, there still needs some other things to be put into consideration and to be done. So I put there that more statistical analysis needs to be done for more interpretation and evaluation. Then I want to check using machine learning in predicting water quality. I have a limited small sample, but I still want to try and use it if I can get something out from it. Thank you for listening.
Thank you so much for the questions, for a very detailed, comprehensive presentation. I'm going to, in the consideration for time, okay, we're just going to give us 5 minutes for comments and questions.
What? I don't know. Say you have limited time. I've done a lot here. And I like the blend of the address with the geochemistry, hydrochemistry. It's really something. But there's not one thing I just want to ask is in terms of ethical clearance of the samples, I mean, your ethics assessment for drinking for, is it for drinking for young adults or for children, right?
Yes.
How are you able to maneuver that? Or you didn't ask any ethical clearance or you reject? Because we have some of those problems when now NRF is making it very important, for any research. They wanted to have an ethical clearance, So can you automatically say, I understand Patrick, I've done it, so I understand what you mean by saying we are just using the general. So, but if somebody, a layman, asks you, like, do you mean this water? Do you test it on children, or do you test it on adults? How do you know it works for them? That's one. Secondly, I'll also look at ecological aspects, in terms of fish, because they use groundwater for farming or for other things. It's also another way to also test. So it's really an interesting one.
That's very valuable comment, especially with the ethical clearances that you'll probably need. Yeah. Thank you. Sorry, you want to pull up, okay.
All in our university, all the students compulsory ethical clearance certificate was obtained from the research department. As proposal and once the ethical clearance is mandatory certificate before submitting the final report. So that time we clearly mentioned what we are using, the contact, is there any direct animal or human or whatever. Then the review, here is so many processes to obtain the ethical clearance. So I think not only that, but all the research students, they must be mandated to obtain it.
So you're saying it's been done for the study?
Right,
okay, it does take a long time.
This study does.
Yeah.
This one.
Okay, all right, perfect. Go ahead.
Thank you again for this presentation. Yes, I want to add a comment like the water quality index. So it's how it varies from WHO standard and even compared to the South African standard of water quality. Which parameter exceeds that limit? And you have done about the particles but it's compared this with the geological or ecological protection in that area. So you have already geological or ecological protection. So which ecology contributes to water quality parameter? So how will this change that state area? That's considered.
You want to comment on that, Victory? Fine. Okay.
Based on the water quality.
Yeah, the groundwater section or geology or geology. The cross section.
Thank you so much, Patience. Well done, guys. Give a round of applause. And we come to the last presentation for the entire workshop. And this is with Mr. Siboniso Inwayo. Let's get your presentation up and running. Is it loaded already?
I uploaded to Dr. Rakesh's USB, but I also have it here.
Okay. Yes. These are the ones that have been uploaded.
Okay. Let me show that. Yeah, this one.
Yeah, that's fine. So Venisa's presentation is on the assessment of microbial and trace metal contamination in the Konjane stream. Can you pronounce this long word for me?
Which one? Wadlangezwa.
Wadlangezwa.
Yes.
Okay, KwaZulu-Natal. Over to you. I don't want to get my time.
Anyway, thank you so much, Professor, for giving me this opportunity. I would like to appreciate to stand in front of this podium, from international professors, national professors, from our guest, universities. And I would also like to extend my greatness to hydrology staff members and my colleagues from postgraduate level. My name is Buliso Ketal. I'm here to give the presentation.
Yeah, please call it out.
Share, yeah. Where this one?
This one. Yes. Oh, yes.
Yeah, that's one.
It is like to this bottom. Say that.
It can be possibly.
Oh, okay.
Use your page down.
Yeah. Yeah.
You were on something interesting. Please take a step back and give it.
Okay. As I was, appreciating my standing in this podium, and Professor Elumalai, my supervisor, was not here when I was extending my gratitude for greeting all, Yeah. So, as I said, my name is Boniso Ketal Nyao, an honors student from Hydrology Department. I'm here to give my presentation based on my project as honors level, based on the topic, saying assessment of microbial and trace metal contamination in Konjane stream, Wadlangezwa, KwaZulu-Natal. So starting from the introduction, the study assessed microbial and trace metal contamination in Konjane stream, of which is a stream that functions as a subcatchment of Mhlathuze River. And the presence of microbial, physiochemical, and trace metal are the key determinant of surface water quality in that stream. So there is a growth there, in human population in the stream subcatchment, which engage a variety of activities that potentially contaminate the stream, and this can lead to some serious healthy issues such as diarrhea from unsafe drinking of this water. So the study is very important for the community well-being and to protect the environment. There are some studies done in the Mhlathuze River, but the case is no studies have been done in Konjane stream. So, and this study will fill that gap, to be the first study that will be done in the area of interest. So, objectively, the study serves to identify hydrogeochemical factors, processes, and identify the sources of
Okay, I think we back online, back on track. Yeah. So can you call Prof as well? It's out there. Have you come to your right? Okay, we're ready to go. And back to Subhanisa, over to you.
Okay, thank you so much, Prof. As I was saying that objectively, the study serves to identify the hydrogeochemical processes, also to identify the sources of this microbial and trace metal contamination, and to understand the suitability of drinking purposes and the irrigation purposes. Where's not
They're using page down. Use page down.
not finishing.
Okay, so we need your help here again. It's breathing.
Which one? This one?
Yeah, this one. That's not my problem.
This one.
Right, under.
This one.
Oh, this one, yeah, not mind that. This one. Research project.
Oh, don't touch.
Okay. Yeah, that one is perfect.
Oh, good.
Yeah. Yeah.
Oh, no.
Okay.
I think we don't be around.
Yeah.
Close by.
Yeah. Thank you so much. I will proceed with the study area of the area of interest. The stream is originating just north of KwaZulu-Natal, south of Mpangeni, and the southwest of Richards Bay major town. So it is 9 kilometers long, which covers an area of 94 kilometers. It's a short stream, but too much of information, I think you will appreciate it. So the temperature within the area of interest has from 21 to 29 degrees in the month of January to March, and June to August, it is ranging from 12 degrees Celsius to 23 degrees Celsius, which is experiencing a maximum rainfall of, from ranging from 850 to 1.2 millimeter. And there were the area of interest is surrounded by, economic agricultural products, and including the sugar canes, citrus and gum tree. And there are some minor scales of developing agricultural landscape. So the area of interest is flat to undulated landforms, steep hills, and flat bottom drainage patterns. It is cultivated by Ongoye mountaineers through the western part of the catchment. Geologically, the catchment is classified by the granites, sedimentary and basaltic rocks, and the clay and silt soils are dominant there, which promote, the rainwater infiltration. So this makes the groundwater to exist within the unconfined aquifers. Following, methodologically, water samples were collected from upper, middle, and the lower reaches in the clean plastic bottles. Total of 11 water samples of microbial collected, and 16 for physiochemical and trace matter were transported to Mhlatuze laboratory for careful analysis, using multi-parameters within 5 hours from the time of collection. So then, the findings were analyzed following the standard limits recommended by WHO of 2011 and the DWAF 1996. So the table there shows the microbial parameters and physiochemical and transmittal parameters. It is there, you see, and the softwares used, the ArcGIS, have been used as a software to delineate the stream catchment and the where it starts, where it ends. So then Microsoft Excel were used for graphical plots, Microsoft Word to type the report. Then SPCC 25 has been used, for statistical analysis. This table shows that the findings found for microbial parameters. You can see there, all the parameters or the findings showed that from all water samples, the microbial parameters exceeded the limit because, the recommended limit for E. coli is 0. And also its reproductive plate count and the total coliform must be not exceed the limit. As you can see, that sample number 9, it detects no coliform found, which means, it means no E. coli found there. As you see there, it is not detected. And it shows that at that point, still the water is not suitable for drinking purposes. As you can see, the heteroprotic plate count and total coliform exceeded the limit. Following this diagram, the Rata diagram has been used to, to understand the one fell below and the ones fell above the limit. You can see there, it shows some of the samples. The blue lines show that from silver, iron, and manganese and potassium, some of the samples fell above the limit, and the red line is represented are those fell below the limit. You can see the pH there, it's varying. That value shows that the slightly acidic to alkaline within the area of interest. I will not go much because of time. You can see the major ions, the one that was dominant. Chloride was dominant, followed by bicarbonate and sodium, as you can see there in the pie chart diagram. And that bar graph shows that how the trace metals vary along the stream. And you can see the ones that exceeded limits, iron in overall, it is silver, iron, and manganese. Following this one, the Piper plot diagram was used, to confirm what type of water is found in the area of interest. And it showed that this is dominated by salt, the sodium and chloride water type, and a mix of calcium, magnesium, and chloride in the area of interest. And that confirm is provided, by giving those graphical plots of, understanding the ion exchange and reverse ion exchange. And you can see there that reverse ion exchange, it's enriched in the catchment, as you can see that, as I said earlier, that it is, a mixed type. And chloride against calcium and manganese and magnesium, it's confirmed that, some of, of chloride comes from anthropogenic activities. And you can say that, reverse ion exchange and the ion, it's likely to be the processes that make that provide that salt and calcium and magnesium water type. Following by Gibbs plots, and it's confirmed that our area of interest it's derived by rock dominance. But however, you can see there some of the data point. The data point represent our sampling size. Some of the data point there, you can see the they plotted outside of, directly rock dominant. It showed that, it showed that a mix of processes. So in that discipline, we can, expect some little of precipitation that's controlling the chemistry of water, some little of evaporation. As you can see there, that diagram, we can see there some of the data point deviated from the equal line. The diagram provided for sodium and chloride, they deviated from the equal line, showing that anthropogenic activities also contribute. As you can see there, I've shown it, that it's a mixed type of water type. And as I found that it's a rock dominant, then I had to make an evidence that which type of rock that, dominate there. Then that diagram of calcium over sodium against 2 bicarbonate, it's confirmed that silicate whether or not rock is dominant there, that which drive the chemistry of water. So following by the correlation matrix, correlation analysis, this one, it gives us that, it tells us more about, the common origin, source of origin that release this ion, metal ions. And it shows that this diagram, massive evaporation process and the dissolution of silicates, rock, and anthropogenic activities. By the first graph there, it showed that one. And the calcium massively correlate positive with the chloride, which, an evidence of expected major process called reverse ion exchange. The primary origin of chloride and sulfate, it confirmed that they were from, anthropogenic activities. You can see there, when, chloride increase, it also increased sulfate, which, suggests the sulfate reduction. There's too much information. You can see there, that graph of silver and iron. It shows that they share a common source of origin. You can see, when the corrosion of maybe, let's say, wastewater disposal, when the water is disposed to the stream, the corrosion of a sewage channel, when this water does have a trace of silver interact with this infrastructure, the sewage channel, they get down there and discharge to the area of interest. This one, was used to find the commonalities and disparities, as it was grouping. Those were coming from the same source of origin, were grouping each other. You can see these were components found there, and there are the hair percentage. You can see the red one, it was derived from agricultural input. As you can see, chloride and sulfate there. And the yellow one, you can see that it was the dissolution of silicate mineral and reverse ion exchange and agricultural input as well. As you can see there, there's a consistent of phosphorus and potassium. So those elements were generated from agricultural input. As you can see, the purple one there, it shows that the chemical reaction is derived from the aluminum silicate weathering. And the blue one shows that chromium is absorbed by the hydroxide under the ideal of pH condition. I tried to show some sources that were dominant to release these metal ions and microbial and the trace metal. You can see that these were pictures have been taken surrounding the catchment. You can see the domestic sewage that contributed to the generation of microbial and wastewater disposal. You can see the galvanized rooftop that maximize the trace of ion, and you see the sewage channel showing the corrosion there. My last objective was from determining the suitability for irrigation purposes. So you can see there and computed index related to sodium. I showed there, that one, the first one showed that the water is excellent. In fact, most of them, they show, but the case is rely, when you can see that one of sodium percentage, you can see that it tells us that the water, we should be doubtful of water there because there's excessive sodium in the water, you know. So by considering this disciplinary scenario, it can inform us that, you know, water, we may be scared of drinking that water without any proper treatment, you know. So in taking in summary with the conclusion, all the parameters tested for microbial exceeded the limit, and for physiochemical parameters, they fell below. Then for trace metal, 3 of them, they exceeded the limit. Followed by the hydrochemistry was dominated by salt and mixed calcium, magnesium, and chloride surface water type, mainly influenced by ion exchange and reverse, or ion exchange or reversed ion exchange, and silicate weathering and anthropogenic activities. So most of the parameters, they correlated positively, which signified that point source and non-point source generated the contamination of this microbial and trace metal. So the water is unsuitable because we have seen that the microbial parameters exceeded the limit. However, based on the sodium-related computed index, they show that it is suitable. However, it was also depicted there that sodium in that water is more concentrated. So there's a need for a proper treatment before the water is used, also for irrigation. So based on my recommendation, I recommended that long-term monitoring and assessment of microbial and trace metal is necessary to minimize healthy effects associated by drinking surface water on the local population. All in all, every drop counts regardless of its fluidity. I'll thank you for the presentation.
The exuberance of youth, eh? How we all wish we were back there. Well done.
Thank you so much.
Ladies and gentlemen, I'm giving you 5 minutes or so to.
I think I will congratulate you and congratulate your school. You will congratulate your supervisor. I'm impressed, you know. It's an honors dissertation. Wow. Yeah. You really surprised me. I'm surprised, I'm telling you. You know, even your zeal, apart from your zeal, the quality of the work, and you should understand what you are doing. And I think it just shows, I think in Zulu, you're pushing it. You need to accept that. All right, it's a nice work. And personally for you, you have a very good future for yourself.
Thank you so
much. It's not gonna be easy. Don't let anybody lie to you. And there's not a lot of money in this field. But be ready to sacrifice. You enjoy it along the line. Just make sure you like what you're doing. And one thing again, when you're in doubt, ask. When your supervisor cannot provide, ask Rakesh. Ask. Yes, God. You know, ask him. You know, they'll guide you. If he's not around, if he's too busy, just don't disturb him. Go to the next person. That is how to play. You understand? And you go from there. And from there, you'll be applying on your own, getting things, you know. And before you know it, you'll be the vice chancellor or even the minister of water resources. Yes. So, but you must start now. You have started very well.
Thank you so much.
So, congratulations.
Thank you, Prof. You know, when you find diamonds, it's in the rough and it's there. You just need to polish it, shape it up, and stuff like that. And he's definitely got the marketing capability there. So I think all in all, excellent. Any other questions or comments?
Yeah. It's a good presentation.
Thank you so much, guys. Thank you, everybody. A round of applause once more for Okay, I'm now going to call upon Prof. Vetri. We've had an incredible 2 days of presentation and knowledge sharing, and we've met some incredible people. I think all in all, it's been one of the most rewarding conferences I've been to for a long time. It's just that it's very short, 2 days, but for some 2 days is a long time. Over to you, Betty. I think you've done an excellent job from my point of view. Props, and you deserve everything, all the accolades.
Thank you so much, Professor Shini, for your words. Really, it was an amazing experience last 2 days. Even I didn't expect this program is going well like this. I believe it's successful program. But already it's too late. I can take few minutes to say thank you for a few peoples. In particularly, I would like to say big thanks to our Vice Chancellor and Deputy Vice Chancellor of the Research and Innovation for supporting unconditionally for these programs. Also, my Dean of the Faculty, Professor Loklanlia, she also highly supporting for this program. She also another main part of this program. Then my colleagues from the Department of Hydrology always behind on me. That's what we are doing. Whatever I'm thinking, if I'm doing, it's because of my colleagues. The tremendous support I'm always getting from them. Then ICT, they're since last 2 days they're spending more time here for sort out all the technical problems. Then my colleague James is here from the CMD. They're taking a lot of pictures and set up the videos, those all. Really, I would like to say thanks. I think from the CMD director is at Sianda. He's a good friend of me. He always helping to develop the new programs. Then my colleague at the secretary of Delhi, Olivia Delhi, she also doing a lot of bookings for programs and the itinerary. These all really, she did good. Then the students, they trust my words. I know how where they came from so long. I think 2,000 kilometers far away. Some of the students is there, Joburg, Uppington, even Durban, all came from so far. But also the Eastern Cape, because of the respect this program as well as me, I believe that's what they all be here. Then I know Rakesh is my postdoc. He's working hard. Last 2 weeks he is really working hard to develop this program. Then Shakile, who was assisted for me to printing and the certificate, something assistance. Really, who is not there here. So I would like to say thanks to. So finally, my guest, from national and international guest, they believe me, they respected my invitations. Then finally they came back, and without their presence, really it's difficult to continue this program as a successful race. But really, I will appreciate your presence here. Thank you so much for your support always. I think that's all. If I miss anybody, please apologize for me. Thank you so much. Prof. Lee, would you like to say some few words, final words? Okay. Professor, I think Prof. Lee, please, you can join with us. We would like to give a certificate for our invited talks as well as the participants. Okay. We have the certificates. We are going to, I think it can take a few minutes, maybe 10 to 15 minutes. Okay.
You want? Yeah. Yeah. Only the first one. No.